You found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Hey there, YouTube. I'm the Dapper Dinosaur, and today I'm looking at a talk given by Stephen Meyer of the Discovery Institute. The Discovery Institute is not explicitly a young Earth organization, although they do have some young Earthers there. Instead, it presents itself as a non-religious organization simply challenging the status quo in science. But that is simply a lie. Because if there's one thing creationists with PhDs are known for, it's lying. So let's read some excerpts from a little work prepared by Meyer himself in 1998 for internal consumption at the DI that was leaked and disowned in 1999, but since then the DI has in fact acknowledged. Their current stance is, quote, so what? It doesn't matter if we lie about our aims publicly. Here are some select bits. The proposition that human beings are created in the image of God is one of the bedrock principles on which Western civilization was built. Its influence can be detected in most, if not all, of the West's greatest achievements, including representative democracy, human rights, free enterprise, and progress in the arts and sciences. Even if true, that doesn't really tell us anything about what science should be doing. Plus, it's an odd way to start out an internal document on a non-religious organization. Phase 3 of Meyer's plan is described thusly. Once our research and writing have had time to mature, the public prepared for the reception of design theory, we will move toward a direct confrontation with the advocates of materialist science through challenge conferences in significant academic writings. We will pursue possible legal assistance in response to resistance to the integration of design theory in public school science curricula. The attention, publicity, and influence of design theory should draw scientist materialists into open debate with design theorists, and we will be ready. With an added emphasis to social sciences and humanities, we will begin to address the specific social consequences of materialism and Darwinist theory that supports it in the sciences. And his governing goals are given in 2 bullet points, the first being, quote, to defeat scientific materialism and its destructive moral, cultural, and political legacies, and 2 is to replace materialistic explanations with their theistic understanding that nature and human beings are created by God. Clearly, the Discovery Institute has no ulterior religious motive. They're just here for science. Yep, indeedly doodly. And here's the thing, I don't actually have a problem with people wanting society to more closely adhere to their ideas. I think we would all like to live in a society that largely agrees with our philosophical and moral ideals, but I do have a problem when people are dishonest about it. Now, that's not to say that I might not have a problem with the ideals and philosophy of honest people. I often do, but that's a somewhat separate issue. Well, now that we know who we're dealing with, let's hear what the good doctor has to say, although we're cutting out almost 13 minutes of irrelevant anecdotes, invocation, and introductions. I've already given Meyer the introduction he deserves.
Anyway, so the book Darwin's Doubt tells the story, and it tells the story of a doubt that Darwin had about his own theory, and how that doubt has grown up to create a major crisis in evolutionary biology today.
It manifestly has not. There is no current crisis in evolutionary biology. There are ideas on the fringes, and there are open questions, but there is no more crisis in evolutionary biology than there is a crisis in chemistry. This is something I recommend reading Todd Wood on. On September 30th, 2009, he wrote a short blog post. While he did then go give an update to it to answer common questions, I'll leave it to you to read that part. It's linked in the description. What I think bears quoting in full is the 3 short paragraphs that make up the body of this post, and I will do so. Again, these are the words of Todd Wood, a young Earth creationist. Evolution is not a theory in crisis. It is not teetering on the verge of collapse. It has not failed as a scientific explanation. There is evidence for evolution, gobs and gobs of it. It is not just speculation or a faith choice or an assumption or a religion. It is a productive framework for lots of biological research, and it has amazing explanatory power. There is no conspiracy to hide the truth about the failure of evolution. There really has been no failure of evolution as a scientific theory. It works, and it works well. I say these things not because I'm crazy, or because I've converted to evolution. I say these things because they are true. I'm motivated this morning by reading yet another clueless, well-meaning person pompously declare that evolution is a failure. People who say that are either unacquainted with the inner workings of science or unacquainted with the evidence of evolution. Technically, they could also be deluded or lying, but that seems rather uncharitable to say. Oops. Side note from Dapper Dino, I don't think it's all that uncharitable given some of the people that, advocate for young Earth creationism or anti-evolutionism more broadly. But anyway, let's continue with the quotation. Creationist students, listen to me carefully. There is evidence for evolution. And evolution is an extremely successful scientific theory. That doesn't make it ultimately true, and it doesn't mean that there could not possibly be viable alternatives. It is my own faith choice to reject evolution because I believe the Bible reveals true information about the history of the earth that is fundamentally incompatible with evolution. I am motivated to understand God's creation from what I believe to be a biblical creationist perspective. Evolution itself is not flawed or without evidence. Please don't be duped into thinking that somehow evolution itself is a failure. Please don't idolize your own ability to reason. Faith is enough. If God said it, that should settle it. Maybe that's not enough for your scoffing professor or your non-Christian friends, but it should be enough for you. While obviously Dr. Wood and I disagree on the ultimate conclusion, we do not disagree about the state of evolution in the scientific world.
That's what the book is about. And I start the book with a line, and I'm going to quote myself. It's a little bit self-aggrandizing, but forgive me. When Charles Darwin finished his great masterpiece, The Origin of Species, he thought he had explained every clue but one.
That's not even close to true. There was a lot that Darwin knew he had not explained. He didn't even know how inheritance worked, although he did have his guess, one that was ultimately shown to be wrong.
The one clue he knew he hadn't explained was an event in the history of life known as the Cambrian explosion.
That is indeed one of the things Darwin did not adequately explain.
And the Cambrian explosion refers to the geologically sudden appearance of most of the major animal groups or body plans.
Yep. Brief in geological terms. Of course, geology represents such a long time that it is an actual running joke with some of my friends that basically any process that is relevant to our lives occurs in the blink of an eye, geologically speaking. The Cambrian period is a period of about 56 million years. A lot of evolution can happen in 56 million years.
And in the way that biologists classify animals, they have a hierarchy of classification. And the biggest group, the phyla, correspond to many different types of animals that exemplify the same body plan, where a body plan is kind of an architecture. It's a unique arrangement of body parts and tissues.
Yeah, that was how it was explained. You know, before we really get a grasp on all the organisms in and before the Cambrian. Now, of course, we have higher classifications that show that even phyla are just variations on a theme. For example, Arthropoda is a phylum, but there are stem arthropods and panarthropods that show that this segmentation and even the genetic basis for it is shared across a wider range of life outside of the phylum. Some prominent examples from the Cambrian world would include Opabidia and Anomalocaris for stem arthropods, and for panarthropods we have animals like Hallucigenia, which is related to the modern velvet worm, and even further afield we have tardigrades. All of these share a common body plan of segmentation with similar organs and similar arrangements in each segment. Similarly, with the chordates, we have hemichordates and urochordates, such as acorn worms and tunicates, that show what might be called the same basic body plan, even as we get outside of true chordata. But going even higher up than that, we have the basic tripoblastic formula, where many bilaterians form 3 germ layers, the ectoderm, mesoderm, and endoderm. All your organs trace back to one of these 3 layers, and which layers is highly conserved across various taxa. But beyond this, the cnidarians and ctenophores share 2 of the 3 germ layers. So maybe there are really only 2 body plans in animals, the germ layer plan of eumetazoans and the basically no plan of poriferans. But of course, at that point, we've gone to way higher classification levels than phyla, and this is ultimately because all of the Linnaean ranks, phylum included, are arbitrary. They are real clades in most cases, but putting a clade in a rank means nothing. There is no objective reason to say that Arthropoda and not Panarthropoda, or even Protostomia, are phyla. Meyer is inappropriately assuming that human conventions are objective parts of reality when we know for a fact that they are not.
So some familiar examples might be chordates, which have an internal spinal column or notochord.
What about tunicates, which have a notochord as a larva? The larval tunicate could be said to share a body plan with true chordates, but they're in the phylum Tunicata anyway, because it's arbitrary.
And the body logic is built around an internal structure.
Okay, Steve, you find me the animal with only external structure. I'll wait.
Another distinct body plan would be things like arthropods.
Hey, that was one of my examples of a group where it actually is really hard to define what we mean by a body plan once we take into account the full modern and ancient diversity of the wider group, Panarthropoda.
And we've got lots of them running around, insects, crabs, and in ancient times we had these things that fascinated me called trilobites, and they have a hard exoskeleton.
But there are parent arthropods that also had an exoskeleton, like anomalocarians. And they aren't arthropods because they lack the thing arthropods are named for, that is, jointed legs. But still, they were segmented protostomes with an exoskeleton. Why do they not count as having the same body plan? Well, because humans arbitrarily say so. You see, this argument is no more coherent than Ken Ham saying that the kind is at the family level, just because he thinks that makes the Ark story seem less absurd when you take it as literal history.
So it's a completely different architecture and logic built around a hard external skeleton.
Okay, but what about onychophorans and tardigrades, which still share the basic arrangement of limbs, segments, and organs as arthropods, but have no exoskeleton at all? They even share the cuticle that grows a protective layer that must be periodically shed. And hey, that cuticle is shared by an even wider group of protostomes, the ecdysozoans, which include panarthropods, but also penis worms, horsehair worms, and nematodes, and coincidentally, are one of Jackson Wheat's favorite groups of animals. Why isn't that cuticle-shedding protostome group the basic body plan? They all share even more fundamental aspects across the group than just arthropods do with each other. Right, because this is still arbitrary nonsense. Meyer is clearly just cherry-picking data to make it seem like God created at the phylum level, even though higher levels just as clearly show common ancestry at levels above phylum.
And many of the major body plans that have ever existed on Earth emerged very suddenly and abruptly in the fossil record in the same period known as the Cambrian period.
Did they, though? Because we have Precambrian cnidarians, and probable Precambrian stem arthropods and stem mollusks, and we have stem echinoderms in the Cambrian that don't even get to be real echinoderms for a while after. What's really going on is that we have an increase in hard body parts in the Cambrian, which makes it easier for fossils to form. So we have more Cambrian fossils than Precambrian fossils. But what Precambrian fauna we do have shows signs of being evolutionary antecedents of the Cambrian fauna. And no, of course we don't have candidate ancestors for all phyla in the Precambrian, but we also don't really expect to for all of them.
And Darwin was aware of this in 1859, and it troubled him because the pattern of appearance didn't really match what he had described in his book, or he had depicted the history of life as a great branching tree, and yet the fossil evidence seemed to suggest that the first animals arose very abruptly with no discernible ancestors in the lower strata that would allow the scientists to connect the dots and form a tree-like picture of the history of life.
There are a few things to remember. First, Darwin was writing at the end of the 19th century, about 150 years ago. Much less of the Earth had been explored for fossils, and we were much worse at finding them and much worse at studying them at the time. That's not Darwin's fault, or the fault of his contemporaries. Science builds upon itself. But pointing out missing evidence, not really problems, mind you, simply then unavailable evidence from 150 years ago, isn't pointing out any kind of problem for modern science. You could just as well say that when Einstein proposed relativity, he didn't have any measurements of gravitational lensing. This is true, but it wasn't a problem, and when people did measure it, they confirmed the theory. This is essentially the state of evolution. There was missing evidence in Darwin's day, and now much of it has been found. Of course, there's always more that could be found, but that's just to say that biology has open questions, like all fields of science.
So this is a diagram. Uh-oh, how far have I gotten? I'm pressing buttons up here and not, sorry. We have an interesting system. My computer isn't hooked up to what's actually going on back there, so sorry about this. Here's a nice picture, by the way, that depicts the challenge of the Cambrian explosion. You see all these different animal forms behind me. On one side, you see the sedimentary rock column, and on the other side, you see the standard geological dating scheme in millions of years.
I was under the impression that Meyer was an old earther and generally accepted science about the age of the Earth, so it's a bit odd to see him calling the consensus ages quote-unquote conventional, as if he thinks maybe they're significantly wrong. Maybe he is even less competent than I thought.
And you see that at a particular point in the history of life, boom, you have these new forms of animal life that arise very suddenly.
Yeah, in this picture, Stevie Boy here made himself to specifically drive home the point he's trying to make. But what if, we looked at the fact that these phyla appear over the course of more than 50 million years, and that they have animals that came before them in the Ediacaran, and we have chemical evidence of animals going all the way back to some 800 million years ago. But that might make his point less forceful, so he presents a misleading and cherry-picked image to his audience. And
as I mentioned, this contradicts the Darwinian picture of the history of life. This was part of his theory was the idea of universal common ancestry.
It doesn't, though. Taphonomic bias doesn't contradict evolution. At most, it prevents us from having as full a picture as we might like.
And he depicted that idea with a branching tree where the forms at the bottom of the tree represented the first very simple, probably one-celled organisms. The branches at the top represented all the complex forms of plants and animals we see today. And then the intermediate, the connecting branches represented what are called transitional intermediates or ancestral precursor forms. Now, the challenge of the Cambrian is represented by this part of the branching tree, which shows the first animals arising.
Nope, there is almost as much time between the first animals and the Cambrian as there is between the Cambrian and now. The Cambrian is more or less halfway through the evolution of animals.
They're represented by the gold dots at the top, but the blue dots represent the expected precursors that the geologists and paleontologists and evolutionary biologists attempted, or is rather expected to see in the lower strata.
And in many cases they do. Look here at some probable Precambrian transitional forms. Spergina, Kimbrella, Wiwaxia, and Namacalathus, just to name a few. Do we know for a fact that all of these are in fact transitional members of stem groups leading to modern crown groups? No, we do not. But Precambrian paleontology is still a young field, and a very difficult one at that. But to pretend that we have no candidates for the ancestral forms of Cambrian organisms is simply inaccurate.
And you can see the problem is that these discernible ancestors have just not turned up. The blue dots represent things that should be there and aren't there. The gold dots represent what's actually there. And so what we see in the history of life is something that looks more like a lawn or perhaps an orchard of separate trees, not one big branching tree that connects up at the base with that first primordial form of life.
Even if that were true, a known fossil transitional form is not required to conclude common ancestry. In fact, the fossil record is mostly superfluous to evolutionary biology. It's the icing on the cake. The layers are made of the morphology of organisms, the patterns of homology and analogy, the nested patterns of genetics and extant life, biogeography, and observed evolution. We don't need a specific organism that looks like the common ancestor of a velvet worm and a horsehair worm to reasonably conclude that such an organism existed. Just like we don't actually need the body of your ancestor to use a DNA test to show that someone is probably your fifth cousin twice removed. The DNA and shared morphology is more than enough to conclude that you two share at least one common ancestor a few generations back.
Okay? And so there's a contrast, a tension between the theory and the data, the theory and the evidence, okay?
No, there isn't.
That's the challenge. And that was the problem. The doubt that Darwin had, not about whether his theory was true. He was pretty convinced he'd gotten it right. But he had a doubt about whether his theory could explain all the relevant evidence, and he was worried about it.
That's not even the point of Darwin's section on the relative paucity of the fossil record. It wasn't that he couldn't explain the evidence. He knew he could, and he could quite well, better than all competing ideas at the time. The section was about the fact that not all the evidence that would have made his conjectures even stronger existed, and so some naysayers would shove their reasons for rejecting natural and sexual selection into the box of so far unrecovered evidence. And he admitted that at the time he was around, there was probably a lot of that unrecovered evidence, and there was the possibility that he might not be able to explain it if it were uncovered, even though he could well explain all the evidence he did have. Basically, Meyer is confusing having no data with having data of non-existence.
And this problem, this tension between the data and the theory, and the absence of those ancestral precursor forms.
Oh, like these ones?
Your
Go on.
Leading up to the first complex animals, I call the mystery of the missing fossils. And this is, the first third of my book is devoted to discussing this mystery.
The mystery of why mostly microscopically small soft-bodied organisms are hard to find in the fossil record. Gee, what a conundrum. If only taphonomy could help. Oh wait, it can. It tells us that soft tissue is less likely to fossilize, that small things are less likely to fossilize, and that as we go deeper into time, less of the sedimentary rock that formed then will be available to study today, so we get fewer fossils overall. Also, let's consider a phylum that we don't see emerging in the Cambrian. Rotifera is a phylum of tiny microscopic organisms with only one hard part, a jaw-like structure. The earliest fossils we find of them are from the Eocene. Note, these are spiralians like snails, annelids, and brachiopods. But they branch away from those before any of them diverged, so according to the scientific consensus, they originate in the Precambrian. So why don't we find any fossils for them for the entirety of the record of life? Is it because they just don't exist and this lack of fossil evidence for rotifers is a serious problem for evolution, since they must have just appeared in the Eocene? Or maybe, just maybe, they have been around that whole time, but being microscopic and primarily soft-bodied, we probably just won't see them? I think my audience can figure out the likely answer.
And here's what Darwin said about it. He said, to the question why we do not find rich fossiliferous deposits belonging to these assumed earliest periods, prior to the Cambrian system, the Cambrian strata, I can give no satisfactory answer. This is right in the Origin of Species. Now, it's really interesting. I really appreciate Darwin because, unlike many of his modern defenders...
First, it's been more than a century and a half. We've learned a thing or two. Second, who are his modern defenders? Personally, I don't particularly care what Darwin wrote. He's irrelevant to science. His importance is in the history of science. All of his writings could be erased, all references to him deleted, and all memories of learning of him gone. And evolutionary biology wouldn't change one bit. Science is not a religion, with a prophet or guru to whom everyone is expected to show deference and believe without question. Darwin was wrong about a lot of stuff, right about some important stuff, and he was a catalyst for scientific advancement. But he wasn't a saint, he wasn't infallible, and what he says currently carries no more weight than the evidence allows it.
He was rhetorically honest. He was rhetorically modest. He didn't try to say he'd solved all the problems when he hadn't. He didn't pound his fist and say anyone who disagreed with him was stupid or ignorant or insane.
Funny, because one, anti-evolutionists usually see that as a sign of weakness. They like their scientific pronouncements full of unwarranted certainty. And two, at the time of Darwin, again, more than a century and a half ago, it was possible to be a well-informed, sane, honest anti-evolutionist. The 16 or so decades in the intervening time have removed that possibility. I'll leave out sanity for now as it's ill-defined, and just repeat that for the three, honest, well-informed, and creationist, one can only be two at most.
But some of his modern proponents do say things like that. A few years ago, I had the chance to testify before the Texas State Board of Education, and they were looking at enacting a policy provision that would encourage teachers to teach the strengths and the weaknesses of competing scientific theories.
Cool, but currently there really are no competing theories in science. There are competing hypotheses within theories, some of which may eventually become theories when they withstand all tests and become the last man standing. Even things like string theory are really at best hypotheses, not theories, and in that particular case, since it has yet, to my knowledge, to make even a testable prediction, it's not even a hypothesis. But of course, we all know what the bill was really about. It was about singling out those aspects of science which some people, for religious reasons, are uncomfortable about, and to lie about how good the data are for them, and to pretend that there is evidence for the truth of religious ideas for which there is no scientific evidence. You're not fooling anyone with this any more than doing a find word and replace for creationists turning into design proponents fooled the courts into thinking of pandas and people wasn't the creationist propaganda that it was. Let's be clear about this, because I've been accused of pulling punches. And I say this fully acknowledging that some of my friends are creationists, and this disagreement does not make me love them any less. But denying evolution is on the same level as being a flat earther. There is no good reason to be either. They are both essentially impossible, and neither can be demonstrated using evidence that is both real and indicative of that possibility over others. Intelligent design and the creationism that it was invented to obfuscate aren't science. They are deceptions intended to keep money rolling in and a certain sect of Christians loyal to the sect. They are not required by Christianity, nor are they even remotely possible in science.
And the Darwin-only science lobby turned out in force to argue against this seemingly common-sense provision.
Yeah, because like I said, we all know that your framing of this is disingenuous. No one was going to talk about the weaknesses of the globe Earth theory and the strengths of flat Earth. No one was going to talk about the weaknesses of electromagnetism and the strengths of believing in Thor. No one was going to talk about the weaknesses of universal gravitation and the strengths of celestial spheres propelled by angels. We all know that the only theory you care about is evolution, which is no less rigorous than those I just mentioned. Really, this here is what upsets me. Meyer is probably not an idiot. I mean, he did manage to get a PhD. He can clearly apply his mind when he wants to. So I have to conclude that he knows this bill wasn't simply a neutral bill all about science. Instead, he knows that it was dishonestly couched that way in an attempt to avoid judicial review. This is reprehensible. Honestly, I'm okay with people advocating for their beliefs being given a place at the table in various institutions, even stupid ideas. What I'm not okay with is them attempting to sneak them in duplicitously. Either own your ideas and advocate for them openly, or just get out of here.
And their argument was, and I quote, "There are no weaknesses in the theory of evolution."
If by weaknesses we mean unexplained phenomena which are significant enough to bring major components of the theory into question, then that's true, there are none. Now, if we just mean things currently not well understood, well, then of course there are, as is the case in all theories. And just because there are aspects of electromagnetism that are not well understood in modern physics, doesn't mean we get to invoke Thor, the god of thunder, as our new explanatory mechanism.
We get it up there? There we go. And this is Eugenie Scott, who was then the president of the National Center for Science Education, a small Darwin-only science lobbying group out of Oakland, California.
You gotta love how much he poisons the well. Their size doesn't matter. They are not Darwin-only. In fact, they advocate for a lot of things that have nothing to do with Darwin, like genetic drift, or heck, genetics as we know it. They are only science should be in science classroom proponents. And what do they think should count as science? Well, the consensus of scientists in any given field, and there is no dissent from evolutionary biology that has any actual evidentiary merit, so ideas dissenting from it are not science.
And when I saw this, I thought this was an incredibly unfortunate statement. I was about to present into evidence 100 peer-reviewed, a binder of 100 peer-reviewed scientific articles questioning various aspects of contemporary evolutionary theory, what's known as neo-Darwinism, the standard textbook theory that we all learn in our high school and college biology texts. So,
oh, congratulations, Steve. You found 100 papers about open questions in evolutionary biology. I'm sure you were shocked to discover that evolutionary biology is a field of active research in which scholars are still raising questions and disagreeing about the answers. I'm not sure what he would expect. A moribund field where no progress has been made in decades? I think we'll find that more accurately describes creationism, zetetic astronomy, astrology, and phrenology. And hey, you know what those all have in common? None of them take the data seriously and instead have predetermined conclusions which they must ram the data into. And no, I'm not going to stop equating intelligent design with creationism because when you look at documents like the Wedge document or the court case around Of Pandas and People, it is clear that all it is Christian creationism trying to pull a blanket of agnosticism over its head in hopes that it will be an adequate disguise.
At the very least, there are scientific problems with the theory, scientific weaknesses of the theory that need to be explored. Darwin was aware of some in his time and talked about them openly, but unfortunately in our modern discussion of biological origins, too many people defending the orthodox view think that they can't acknowledge the actual state of the science that is in play.
I would love for him to give us an example of such weaknesses instead of simply complaining that people say they don't exist. This is exactly the same tactic as a flat earther saying that they'll believe in the globe if shown evidence, then being shown evidence and simply declaring that it doesn't count for some reason they've made up on the spot. Because the real answer is that what would convince them is nothing. But they know being open about that makes them look bad, so they pretend that the supposed lack of evidence is a problem for the globe, even though there is no lack of evidence.
One of the worst offenders in this regard is the well-known evolutionary biologist and new atheist named Richard Dawkins from Oxford University. He's actually said it's absolutely safe to say that if you meet somebody who claims not to believe in evolution, that person is ignorant, stupid, or insane. And then he said, in parentheses, or wicked, but I'd rather not consider that. And I thought that was really sporting of him not to consider that maybe the people who disagreed with him were wicked.
It is sporting of him, because many of them are demonstrably wicked liars. We know for a fact that people like Andrew Snelling, Kent Hovind, and Meyer himself are deeply dishonest. It's not often that I would defend Richard Dawkins or care much about what he says at all, and it's even more rare that I would say that he inappropriately held back in his criticism. But here he certainly did. Many professionals and even some amateur creationists are demonstrably liars, bigots, fraudsters, and genocidal maniacs. Not all of them are, but the ones who are certainly motivated to be so by the same basic beliefs that motivate their anti-evolution stances in the first place.
That's not rhetorical modesty, that's rhetorical excess. And there's an awful lot of it in this debate. And
gonna have to disagree. I think it is inappropriately restrained.
So I do appreciate that Darwin was so honest about the things that he could and the things that he couldn't explain. So his statement here, the evidence from the Cambrian explosion at present must remain inexplicable and may be truly urged as a valid argument against the views here entertained. So that's what I call the mystery of the missing fossils. And it haunted Darwin to his death, but he did have, he was a smart guy, and he had an idea about how this could be resolved. He thought that, let's see, I'm coordinating my forces here. Okay, mystery of the missing fossils, ta-da. He thought that the absence of these ancestral intermediate forms would be eventually explained away by future fossil discoveries, which is to say that the missing forms would actually turn up.
Well, cool that we already found some then, isn't it?
If we kept looking hard enough in the pre-Cambrian strata around the world. So he had this charming analogy to a book, that the fossil record was like a, he said, I look at the natural geological record as a history of the world, imperfectly kept.
Seems like it is, given that we can be pretty sure that rotifers didn't just pop into existence in the Eocene, which would violate even Meyer's idea of phylum coming de novo out of the Cambrian.
And on this view, the difficulties discussed above about the Cambrian explosion are greatly diminished. So he said, imagine that the fossil record is kind of like a book, and it's recording some of the layers are there. They're like a chapter, but then other chapters here and there are missing, and some chapters we may only have one page. And eventually, if we find the other pages and the other chapters, then it will show this seamless, gradual, continuous, changing progression described by his history of life depiction of the origin of all the new forms of life on Earth.
Well, that's overly optimistic in my opinion. There is no reason to think all species have left fossils, and that all species who did still have fossils extant, as opposed to being weathered away or subducted into the mantle. We only find that subset of organisms that 1. Were fossilized, 2. Whose fossils survive until today, and 3. Who are still in strata exposed and accessible to humans. That is of necessity only a small fraction of the organisms ever to have existed, so expecting such a record to be seamless and complete is, to put it mildly, supremely optimistic.
So that was his hope. And this idea became known later as the artifact hypothesis. The idea there is that the absence of those fossils in the lower Precambrian layers,
which is now a relatively lower abundance of fossils, not a lack, let's remember,
are an artifact or a byproduct of our incomplete sampling of the fossil record. We just haven't looked hard enough. And another version of that same idea, well, a slightly different version, but the same kind of concept, was that the missing ancestors are an artifact of incomplete preservation. Maybe there was something in those in the sedimentary, the sediments that were in the Precambrian that were just not capable of preserving.
Like rotifers. Hey, we already showed this hypothesis to be viable. Neat how some basic knowledge of zoology and taphonomy can do that.
Those ancestors. Maybe they were too small. Maybe they were too soft to have been fossilized.
He just keeps describing rotifers, and I kind of love it.
So that was another idea. That said, so either it was an artifact of incomplete sampling, inadequate sampling, or incomplete preservation. And that idea became kind of the go-to explanation as to why these fossils were missing.
So here I really hope he's going to tell us why he thinks that there is no taphonomic bias in which organisms are preserved, and why we have reason to think that we have a nearly complete sampling of all paleoenvironments from all places at all times. Otherwise, he hasn't really changed this idea. And of course, I'll keep saying it, they're not all missing.
Now, unfortunately, for the defenders of Darwin's theory, additional fossil finds have not actually resolved the mystery of the missing fossils.
It's not at all mysterious, really.
They've actually made the mystery more acute. In Darwin's time, there were several main forms of animals that were known. There were these trilobites, which fascinated me as a kid. They look kind of like potato bugs, if you've watched those guys. But I forgot, I have a really nice sample of one that has a compound, you can see the structure of the compound eye in the fossil that I have. And it's just, you realize that it was a very sophisticated visual apparatus from the very beginning, from the dawn of animal life. It's extraordinary how complex these animals were.
From the dawn of animal life, huh? Well, the first trilobites appear in the fossil record about 521 million years ago. Weird how in 2021, the body fossil of an 890 million year old sponge was found. I wonder, does 369 million years from the earliest animal fossil count as the dawn of animals? Just to put that into perspective, there was about as much time between the first known animal fossil and the first trilobite as there is between the first fish to crawl on land and you. We're talking about the Famennian stage of the late Devonian. Amniotes hadn't evolved. Land was still almost exclusively the domain of non-vascular plants and arthropods. Sharks were still the new kids on the block. Somehow, I think 369 million years is enough time to figure out an eyeball or two.
And Darwin knew about these guys. He also knew about other animals called brachiopods and several others. There were several main groups. But in 1909, there was a huge fossil find. Do I have a picture of Canada behind me? Okay, thank you. I didn't want to keep turning around. How interesting can the back of my head be, right? And right near the border between British Columbia and Alberta, in a place near Field, BC. And these fossils were discovered by a paleontologist named Charles Walcott.
At this point, Meyer goes on an aside about the conditions of Walcott's prospecting. I can't see how that's relevant, so I'm cutting it out.
And as they pulled the horse out, he flipped one over, and it revealed an amazing, delicate lace crab.
That's Morella splendens, which isn't a crab at all, by the way. It's not even a crustacean. It's probably a stem mandibulate. But even that is unclear given how basal much of its anatomy is.
An animal that had been previously unknown, and unknown to this period of time, and you can imagine the winter that Walcott had waiting to go back to see what other treasures lay in these hunks of shale, which later became known as the Burgess Shale.
Primarily more of the same, as M. splendens is the most common fossil, but there are lots of other neat stuff too.
And he did in fact go back, and the Burgess Shale, this is an artist's depiction of that lace crab.
I want to point out, because Meyer hasn't, but lace crab is not referring to any modern group of animals. These are animals that went extinct long before any crustaceans evolved a crab-like form, and it didn't even have one itself. Lace crab was just an informal term Walcott used. It has no scientific significance, and even though Meyer is using it like it's a common name of some living animal group, it is not.
And he went back, and it was a trove of new animal forms. Here's another guy called Waptia.
Waptia is a genus of so-called bivalved arthropod. It's not quite a crustacean, although we're getting closer, and it is almost certainly in Crown mandibulata. You see the beautifully segmented, articulated exoskeleton there. It looks like a shrimp with a hard head shield. Here's a picture of another fossil of this guy from another locale with a beautiful artist's rendition. But you can see that, there were just all kinds of interesting. This guy, this guy's called an Opabinia. Opabinia is in fact a stem arthropod. That means it's technically outside the phylum Arthropoda, just like velvet worms. But this puts the lie to the idea of phyla representing body plans with no higher nesting or transitions. Opabinia is clearly closely related to the arthropods, yet it would be in a different phylum in today's classification system. That is because at the opening of the Cambrian, the time since the various phyla diverged was similar to the time between today's classes or orders. That is, Opabinia is as related to Morella as you are to a bird, yet they would end up in different phyla. As we go back in time, all life at that time is more related to each other than their descendants are to each other because, there are lower divergence times involved. Basically, as we go through time, evolution occurs at what we see, on the whole, as lower and lower ranks. Not because anything new is happening, but simply because the tree can only branch as it goes forward, so of necessity, new evolution appears at lower ranks. If you were to study the Cambrian back in time in real time without knowledge of the future history of life, you'd probably put Opabinia and Morella in the same phylum, possibly even the same class, maybe something like Segmenta or something like that.
He has 5 eyes, a long proboscis, and I think it's about 30 segmented body segments. Stephen Jay Gould, the famous Harvard paleontologist, wrote a book called Wonderful Life, all about these extraordinary animals that were discovered in the Burgess Shale. So whereas before we had a few basic forms of animal life that we knew had arisen, or that the paleontologists in Darwin's time knew had arisen in a really discrete and abrupt way, now as a result of the Burgess Shale, there was, and I'm showing a bunch of, this is a guy called Wewaxia.
Probably a stem mollusk, which again puts the lie to Meyer's claim about the distinctness of the phyla. As a stem mollusk, it's outside the phylum Mollusca, yet it clearly has a similar body plan with a dorsal shell over a mantle and presumably a ventral foot-like organ. Yet it's not quite a mollusk. It's almost like Meyer's own examples show that his main talking points are nonsense.
All these are animals. This guy kind of scooted around the bottom. Now, as the result of the Burgess Shale discoveries, there are loads more animal forms whose first appearance is documented in the Cambrian period,
and who demonstrate the evolution of phyla from within even higher categories, most of which are unranked. Because again, the ranks are arbitrary, and saying that phyla is where it's at is really just as silly as when Ken Ham picks families for where he thinks common ancestry stops. Both are simply arbitrary stopping points chosen because going any higher makes the creationists in question uncomfortable.
And each of whom lack ancestral precursors in the lower Precambrian strata.
Some do, some don't, which is what we expected. Unless, of course, Meyer is going to argue for the complete perfection of the fossil record. I now wonder if he'll even try.
So now, from our vantage point, we've discovered that the Cambrian explosion was much more explosive than it was understood to be in Darwin's time.
No, it's just the first radiation of hard-bodied animals, that's all. And it also took tens of millions of years, and it was preceded by hundreds of millions of years of animal evolution. The first radiation of hard-bodied animals had to happen sometime, and that was always going to look like a sudden burst onto the scene of lots of animal life, simply because of taphonomic bias for hard mineralized parts.
The mystery of the missing fossils wasn't attenuated or mitigated by fossil finds, it was accentuated, it was made more acute.
Except it wasn't, as I just described. We found clear evidence of things that were closely related to crown members of modern phyla, but weren't quite them, which is exactly what you'd expect to see if common ancestry goes back further than the phylum level.
Oh, okay, now this is the next big fossil find. 1984 in southern China. There's another huge Cambrian discovery. And it was very exciting. In the 1990s, they ended up doing a cover story on it in Time magazine with the title, Evolution's Big Bang.
I'm honestly not a huge fan of that title, but whatever.
And one of the paleontologists who was commenting on this find, it was extraordinary for a number of reasons. The preservation was even more exquisite than the fossils at the Burgess Shale. There were more new animals discovered than had been known even from the Burgess find. So the explosion again looked more explosive, more new forms of animal life, again each lacking those ancestral intermediates.
Well, we haven't been told what any of them are, so I can't say if that's true or not. It'd be nice if instead of paraphrasing what some unnamed contributor to a National Geographic article said, we were told what was actually found and perhaps some citations so we could look things up about said organisms.
And the time period in which geologists estimated these events to have occurred shrunk quite dramatically. And so
I don't really care to check on that. If true, it still shrank a period of time still best measured in tens of millions of years. That's not exactly overnight, even for evolution.
One of the paleontologists quoted in this article said, well, what I like to ask my evolutionary biologist friends is this: how much faster does this event have to get before we stop calling it evolution?
You have to show that it couldn't happen that fast. Now, I don't know off the top of my head how fast that would be because I don't know enough about the organisms involved to talk coherently about things like generation time and expected rate of morphological change, but I'm going to say that it's going to have to be shorter than, the almost 400 million years since the earliest known animals to count as a time too short for evolution. Maybe under 1 million years would do it. Maybe that's too extreme. It's a weird question to ask given that so far nothing here has hinted at a lack of evolution, and in fact, the predictions of evolution have been borne out instead.
It's really abrupt, okay? So this accentuated the mystery. And in the year 2000, we had a...
Oh, okay, we're just going to say that 1984 was a mysterious year for scientists, and that all that happened was they found some unnamed Cambrian life and that some guy talked about it in Nat Geo. Then we're going to talk about something 16 years later. Sure, why not? It's not like the actual finds in 1984 were important to this topic or something. is a lot of ramble about how that scientist went to Washington and showed off some fossils. It's boring and irrelevant, so I'm cutting it out.
This is a guy called Anomalocaris. He is he was the top of the food chain predator in the Cambrian seas, about 1 meter long, extraordinary, and the preservation of the body parts and tissues. It was another arthropod.
Except no, we have another stem arthropod. In this case, a whole group of them called radiodonts. Weird how, if each phylum is a unique creation, we keep finding things that are almost members, but not quite. One of the ways you can tell that this guy wasn't an arthropod is that the name arthropod literally means jointed legs, because that's a characteristic of the group. And what didn't radiodonts have? Right, jointed legs. Weird how that works, isn't it?
Extraordinary creature. Another animal that was discovered representing the phylum Hyolitha.
Weird how both Hyolitha and brachiopods, which are still alive today, are both brachiozoans. So do they have the same body plan, or is this more evidence of the emergence of the brachiopod from within a wider spiralian group of organisms? Hard to say, except yet again, Meyer is presenting animals that, rather than being a problem for the idea of common ancestry at higher levels than the phylum, are in fact evidence of it.
This Hyolith was an animal that lived inside a conical shell that had an attached lid that opened and shut. Another interesting body plan.
But that body plan is a top and a bottom shell with lophophores. So is that the same body plan as a brachiopod or bryozoan? Why or why not? It's not a member of either phylum, yet it has this common structure. Weird, it's almost like evolution happened within brachiozoa, at levels above the phylum.
Different kinds of worms, a fourninid worm that had a feeding organ and a thing called a lophophore.
I mean, really? Well, we just went over Lophotrochozoa, a superphylum. It's like Meyer is just doing my job for me.
A worm inside a tube. The worm lived inside the tube. But then another kind of worm, an annelid worm that was segmented and had lateral bristles for locomotion.
So yet more variation on Lophotrochozoa, again, a superphylum. Weird how much diversity there is around phyla before we even get to the diversity within phyla.
So lots of distinct body plans and architectures.
If by distinct you mean falling into a nested hierarchy of the same kind that Meyer accepts lower in the taxonomic tree as indicating common descent, then sure. Although that's not how I would use the word distinct.
Exemplified by these different animals. This guy I really like. It looks kind of like a plant, but the more they studied it, the more convinced they were, the paleontologists, that it was an animal.
Yup, and given its rarity and the small size, it's a bit of a mystery what it is. Although it wasn't first discovered in China like Meyer implied, but in the Burgess Shale. It's just that now the majority of specimens are from China. I'm not sure how that matters, and I'm also not sure what the existence of enigmatic fossils is supposed to mean for his point.
But the organization of this animal, called Deinamiscus, was so unusual, they didn't quite know how to classify it, so they just called it a problematica.
In fact, its affinity is still problematic. Like, you know that was the case for most Cambrian animals when they were first discovered. It's almost like that's how science works. It starts out not claiming undue certainty, and then when there are open questions, it seeks new data to try to come up with the best explanation possible. Unfortunately, when it comes to Deinamiscus, we have very little to go on. It's not an invitation to invalidate all the things we know, though.
You can see, ladies and gentlemen, how science works.
Cautiously, openly, and honestly, if I'm basing it on this example. I really hate how much creationists treat scientific caution and reserved language as if that means the whole enterprise were in question. It is the very caution, humility, and willingness to be shown to be wrong that makes science the powerhouse that it is in terms of explaining the natural world. Only by being honest about what we do and do not know, how well we know it, and how we could be shown to be wrong, as well as the willingness to see if we are wrong, and accept it if we are, has science managed to get past any wrong answer it might have gotten in the past. It is why we can trust science. Anyone who comes to you claiming certain knowledge that can never be challenged, even in principle, about the natural world is someone you should steer clear from, and creationists often fit that description.
Okay, so that was kind of neat. So we were getting a really good fossil show. Oh, and this guy's my favorite because we have these in the Puget Sound where I live, near Seattle. And this is extraordinary. This is a comb jelly. And you can see, let's see, the picture on the left is a photograph of a modern translucent comb jelly. And the picture on the right is the artist's depiction of what's being shown by that Cambrian era fossil. So on the standard geological time scale, This guy's been around for 520 to 30 million years, and he hasn't evolved at all. This is a phenomenon that paleontologists now call stasis.
How do we know it hasn't evolved? Do you have a complete genome and anatomical description of Mautianoscus octonarius in your back pocket, Steve? I didn't think so. Anyone can point to a morphologically conservative organism in the modern day and look at an earlier form and say, hurt to her, where to evolution go? Guess what? Doesn't mean there was none. But just looking at this, I see differences in the bell and mantle shape, as well as a difference in the pairing of cilia tracts. So I guess that's where it is.
Which is a lack of directional evolutionary change.
Organisms well adapted to persistently stable niches not undergoing large morphological change is an actual prediction of evolution. The fact that stabilizing selection is a thing isn't a problem for evolution, it's a prediction of it. It's like pointing out that Pontius Pilate was a real person and saying that's a problem for the Bible. Even though you'd expect him to be real based on the fact the Bible talks about him as the Roman governor who sentenced Jesus to crucifixion.
Things just stay the same for a long period of time. Kind of mysterious on a Darwinian point of view.
Nope, not if you're well adapted to your niche, such that significant morphological changes away from your current form are always maladaptive. Then it is perfectly in line with evolution, although Darwin has nothing to do with it. After this is more anecdote about Professor Chen and how he supposedly questioned evolution. I have no way to verify any of this, so I feel like it's not worth responding to. Additionally, it's not what some guy in some lecture hall says, it's about what's in the literature, and that does not in any way support Meyer's position. Meyer also talks a bit about early chordates. He doesn't make any new points.
And at a certain point in his talk, he said, you know what's extraordinary about these fossil forms, and he held up his hand like this, and he said, is they turn Darwin's tree of life upside down. So now in the Darwinian tree of life, the little changes accumulate over long periods of time, eventually resulting in big disparities in form.
You mean how lots of things are just kind of vaguely worm-like in the Cambrian, then stem groups like stem arthropods and stem mollusks arise being more distinct, and now the members of the phyla that they represent are even more diverse and distinct than their stem group ancestors? Yeah, go on.
A chordate is really different than an arthropod. That's a completely different body organization.
But it's not completely different from a hemichordate or urochordate. It's only a bit different.
Theoretically, from a Darwinian point of view, those two forms of animal life would have had a common ancestor way, way, way back.
Yeah, the first bilaterian animal. But guess what? We have a fossil that matches what we would expect of such an organism, Icaria wariutia, from about 550 million years ago. You know, about 15 to 20 million years before the Cambrian. Such explosion, much boom. Wow.
So it takes a long time to develop those big differences, and they only arise at the end of a long process of gradual evolutionary change.
Well, given that the difference between phyla is, as we have seen, not as distinct as Meyer would like to pretend, and that we have tens of millions of years at minimum to work with before even getting to the Cambrian, seems fine to me.
In the Darwinian theoretical perspective.
I swear, I should start a drinking game where I drink each time a pseudoscience enjoyer uses the name Darwin for no reason. After this, he just said that Dr. Chen agrees with him, and haha, censorship in China doesn't censor him from saying stuff about evolution or lack thereof. I don't care about that. I don't think that the exchange actually happened as Meyer presents it, so I'm skipping it.
Oh yeah, I love this guy. This is one of the earliest fishes ever discovered in the Cambrian, right from the very beginning.
It's only from the beginning of the Cambrian, if by that you mean more than 20 million years into it, and having been preceded by more basal chordates, and being surrounded by almost, but not quite chordates, then sure.
Now, even as ardent an advocate of evolutionary orthodoxy as Richard Dawkins.
I'm not defending a 1986 Dawkins quote that's taken out of context. Do better, Meyer. Cite some research that's actually peer-reviewed and not ancient. Basically, Dawkins was talking about gaps in the fossil record, some of which have been filled, in the context of the then hotly contested arguments over punctuationism and gradualism. Since everyone agrees that there are gaps in the fossil record, and since they are not per se a problem for evolution, and since they are fewer and fewer, I really see no reason to engage this.
By the time 1984 and the 1990s and right up to the present, there are very few paleontologists who any longer think we haven't looked hard enough for the ancestors in the Precambrian.
Really? Because I just mentioned and linked in the description a paper about the discovery of an organism from the Precambrian that looks an awful lot like what we'd expect for the ancestor of all bilaterian life. That's like 33 phyla or something. Seems like more looking has indeed paid off.
But up until relatively recently, there were still a lot of people who thought, well, maybe we're missing the ancestors simply because they weren't preserved. And the most popular version of the artifact hypothesis was that they weren't preserved because the ancestors were too small or too soft.
And we're back to the rotifer problem from last time. Explain why we don't have fossil rotifers until the Eocene, but evolution needs all the ancestors of all phyla to be found in a smooth transition in the fossil record with the same explanation, without special pleading, Steve, or it's time to GTFO.
But the Chinese fossils revealed something relevant to that claim as well. And that was a really interesting find in a layer of rock just beneath the layers that document the Cambrian explosion.
Oh, good to know that Meyer knows that the Cambrian isn't the dawn of animal life. Weird then how he'd lie about that when talking about trilobite eyes earlier. It's almost like he doesn't care about actually being honest, just scoring rhetorical points. Next thing you know, we'll have to dress him up in a Superman outfit and give him a bad haircut.
This is a layer called the Dishonest shale, and in this shale, it's a very late Precambrian sedimentary layer. The Chinese paleontologists have discovered little tiny microscopic fossils going through the first few cell divisions. They're embryos.
Of course, when he says they're late Precambrian, he is being a bit misleading. Many of my readers are familiar with the mistaken point biota, which is what most people think of when they think of Ediacaran life, organisms like Spergina, Charnia, and Dickinsonia. Well, this formation predates even that, which may at least in part explain why all the fossils are microscopic. It may be that this predates even the evolution of macroscopic scale animals. Of course, we're still looking at about 300 million years of animal evolution between the earliest animal fossils and this assemblage. It has also been proposed that given the unusually consistent size of the fossils, which is extremely unexpected, that there may have been some taphonomic process that prevented larger or even smaller fossils, because remember, we're also not finding smaller bacteria fossils. Or at least none have been reported that I can find. And similarly, while there are microscopic sponges and corals, none are even approaching the size that we find at Mistaken Point, which seems hard to explain without some mechanism keeping larger organisms out of the fossil-bearing rock, even under Meyer's ideas. And of course, all of this is assuming that they are in fact animal embryos, which itself isn't completely agreed on.
Probably of sponges, a very simple animal form, one of the few animal forms that originated in the late Precambrian.
Well, except we also have cnidarians from the Dishonest shale, and that's quite a bit more complicated than a sponge. Also, while this is disputed, there have been reports of potential bilaterian embryos and even microscopic adults. That is something I bet he doesn't bother reporting on, since it would throw a monkey wrench into his point of see, this one fossil site doesn't have the ancestors of various modern phyla, therefore no such thing exists. Which is already an obviously bad argument. And one of the reasons I'm pointing out all the contentions around the forms found in the Dishonest shale is that it's actually not well established what's being found in this rock. Basing our picture of the time before the Mistaken Point Ediacaran biota evolved on the basis of this is at best premature. It is already difficult to interpret, and independent of any Meyer nonsense, there is good reason to believe we do not have a clear picture of the taphonomy of the location.
Now, this discovery raises a huge problem. It produces for the artifact hypothesis. And it's this: if the late Precambrian sediments are capable of preserving small microscopic fossils,
but not the larger fossils, which apparently they can't, even though there's every reason to think those tiny embryos grew into larger animals, in at least some cases, which are not preserved. First, probably the same reason they tended not to preserve the adults of the embryos we find. And second, the Precambrian rocks probably did to some extent, over in Canada.
Why didn't they preserve the ancestors to all the other animals that first arise in the Cambrian? The fishes, the trilobites, the animalocarids, all these other guys.
Chordates do in fact have pretty obscure origins, but there are potential panarthropods in the Ediacaran, just, not in the Dishonest shale. It must be so much easier to be a pseudoscientist hack, where you get to just ignore most of the evidence and cherry pick, misinterpret what you did cherry pick, and then make a bit more up, and your audience just laps it up because you're not one of those evil materialists. Even though many of the people who are actually doing the real work of science are also not philosophical materialists.
Especially since most of them would have had to have some, at least, hard parts, because they're animals with hard exo or internal skeletons.
Well, that's just a lie. Hard parts, that is mineralized parts, aren't ancestral to bilaterians and don't appear until well down the tree somewhere past superphylum. And even within organisms that he's shown as examples of modern phyla with hard parts, we've seen things that didn't have bones or other mineralized parts, like his early fish, or Morella, which had a chitinous but not mineralized exoskeleton. Even with the phyla that probably do have hard parts as the ancestral forms, such as Brachiopoda and Mollusca, we can see other members of the superphyla that lack such structures, some of which Meyer even showed us.
So now I would say the dominant view in Cambrian paleontology, especially among the leading experts on the explosion, is that the explosion is real.
Well, yeah, it's what you call the tens of millions of years long radiation of hard-bodied organisms during the Cambrian period. That was never in dispute. No one ever said, nah, nothing significant happened in the Cambrian. The question is, can it be well explained by current ideas in evolutionary biology? And the answer is yes. Something big happens every time there is a major radiation of any organisms, but adaptive radiations are part of the evolutionary theory, not a problem for it.
It's not an artifact of incomplete sampling or an incomplete fossil record.
Funny then that the example we are shown to demonstrate that can't really be well explained without that, and that Meyer has yet to actually argue for the idea that the fossil record is substantially complete in terms of both geologic and temporal extent, such that we should not expect to be missing any species which have existed. Which is basically what he needs to do to be able to say that we should expect known fossils representing the evolution of all phyla.
There was a very important book on the Cambrian explosion that came out in 2013, the same year as mine, by James Valentine and Doug Irwin. And they basically, there's no friend of my preferred perspective, which I'll explain later, but they very much think that the Cambrian event was real, and whatever we make of it, they argue, we've got to reckon on the explosion as being something that really happened. It's not just an artifact of incomplete sampling or incomplete preservation.
Yeah, no one is saying it didn't happen. That's a mighty fine straw man you got there, Steve.
Now that's the first mystery of that I address in the book.
The mystery of why new niches result in adaptive radiation isn't really a mystery. So let's go into this a bit. Adaptive radiations are related to niche partitioning, and so I'll start with that. Niche partitioning is what happens when you have more than one population competing for the same bundle of resources. So let's say you have two kinds of squirrels who are both eating chestnuts and acorns. Let's say the brown squirrels are, for whatever reason, a bit better adapted to get chestnuts, and the red squirrels a bit better at getting acorns. The exact details of why is not important. All that's important is that this difference exists, and it is for reasons that can vary as genetics vary. Now, they both compete with each other for both kinds of nut, making life harder for both populations. But the brown squirrels have to compete less for chestnuts, and the red less for acorns. So any variations that make the brown squirrels even better at exploiting chestnuts, or the red squirrels even better at exploiting acorns, will be on the whole more likely a bigger advantage than variations that do the opposite. As a result, over time, the red and brown squirrels will tend to compete less and focus more on the food that they are now beginning to specialize in. In the long run, if the environment is sufficiently stable, they will likely end up eating their preferred food almost exclusively and essentially eliminating any interspecies competition between them. Now, let's look at something similar in the real world. About 150 years ago, the hawthorn maggot in North America found that the relatively newly introduced domesticated apple was a good host for its young. Before this, the fly larvae had specialized in parasitizing the hawthorn berry, hence the name. But a whole new niche became available. Those flies that could lay eggs on apples suddenly found that they were no longer in competition for hawthorn berries, and so reproduction became easier for them. But still, there were flies that were either not very good at using apples or simply not inclined to use apples, and so they stuck to the hawthorn berries. Now at this point, the two populations no longer interbreed because as time has gone, the apple maggots, as they are now called, became specialized, and so they timed their breeding to the seasonal cycle of apples, not hawthorn berries, which is sufficiently different that the two populations simply breed at different times. These populations have essentially speciated, and one segment of the original ancestral common hawthorn maggot population has filled a niche that didn't even exist not that long ago. These are small-scale examples of how niche partitioning, along with the advent of new niches to fill, can cause species to multiply. Now, niches can become available in two big ways. The first is that a new resource is suddenly available to organisms, such as in the apples in North America. The other is that previous occupants of a niche go extinct. For example, if the current apple maggot population were driven to extinction, perhaps by humans, it is likely that in a few hundred years some new population of insects would begin parasitizing apples, simply because that's an energy source and lifestyle no one else is going for, and so they would be largely free of competition. So what happened in the Cambrian? Well, remember, to exploit a new niche, an organism must be capable of at least poorly occupying the niche. And the Cambrian largely represents the beginning of mineralization of body parts, which allowed organisms to become bigger and more active on the whole. This opened up the possibility of active predation rather than just rooting around in the muck or suspension feeding. But active predation is often best avoided by active organisms, which thus resulted in harder, bigger, more active, and perhaps even smarter prey. But also, being more active allows for more complex behavior, such as migration, creating burrows, even social interactions. Suddenly, because of the advent of mineralization, there were all new niches opening up all over the planet, and an evolutionary arms race between predator and prey was set off heavily favoring organisms to either get fast, get armored, or in some cases, both. At this point, morphologically speaking, evolution was off to the races. There was now a reason to evolve efficient fins, legs, eyes, armor, skeletons, claws, spikes, you name it. That's what the Cambrian was. It wasn't magic, but it also wasn't a non-event. But neither was it instantaneous, as Meyer is implying.
The second one has to do with what you really can think of as, first of all, it's a deeper problem, and it's an engineering problem. It's the question of how would the evolutionary process build all this new form and structure?
By co-opting the already existing regulatory architecture. For example, the regulatory genes that govern limb, eye, gut, and segment development in panarthropods is the same, but it's also the same in chordates like you. You use the same regulatory genes as a fly does to grow an eye or a leg. In the ancestral bilaterian, these genes were probably not being used for the exact same purpose, but ultimately these developmental genes are the genes that tell embryonic tissues to fold, grow, die, or differentiate. And that's essentially all that happens in an embryo. Just doing these things in different amounts at different points and at different times. The potential for a simple tube within a tube worm to become any of the phyla that we now see is already there, just waiting for mutations to occur to make their development follow more complex paths. This is no longer a mystery. Evolutionary biologists know how this happened, and in some cases can even identify the mutations that had to occur to get the various body plans from the basic bilaterian ancestor.
Especially in such a short period of time, geologically speaking, and biologically speaking.
I don't think a few tens of millions of years is such a short time, and Meyer hasn't even begun to argue that it is. He's just asserted it.
The natural selection random mutation mechanism needs a long time to work.
In most cases, it needs at least a few tens of thousands of years to get serious morphological change done. But, we have a few tens of millions of years, and there are cases where it can happen faster, such as in environments conducive to punctuated equilibrium, where small populations can evolve much faster because genetic drift is less likely to eliminate new variation just because of the law of averages.
And scientists can actually, there's a branch of evolutionary biology that allows scientists to actually calculate what are called waiting times.
By this, he's mostly referring to creationist nonsense, but we'll see where he goes with it.
If you know the size of a population, the mutation rate, the time from one generation to the next, factors like that, you can calculate for any given series of mutations how long you should have to expect for such an event to take place.
No, not from those variables. The mutation rate doesn't matter, and oddly enough, neither does the generation time. What you actually need is the phylogenetic replacement rate, because that already factors into it the loss of mutations from things like failure to reproduce, genetic drift, and the difference between somatic and germline mutations, which the mutation rate does not do. And you also get to factor out the generation time. But you'll need the crossover rate, because mutations in separate lineages can become linked during chromosome crossover in meiosis. At this point, it's probably worth it to discuss crossover. This is something that happens during meiosis, which is the process by which germline cells produce gametes. So for humans, that would be sperm or egg cells. As you probably already know, humans are diploid creatures, meaning that they have 2 copies of each chromosome, with the possible exception of chromosomal abnormality, which leads to sterility, or sex chromosomes which may not be able to pair up if an individual has an X and a Y chromosome. When 2 of the same chromosomes line up in this case, on average, each one swaps part of itself with its twin, so that the alleles on one chromosome cross over with the other and vice versa. This helps break up what are called linkage blocks, that is, whole sets of genes that are associated with each other and tend to be inherited as a group. This is what prevents most chromosomes from simply being completely independently evolving lineages that must be taken or left as a whole, which is the case for mitochondrial and Y chromosome DNA, which is why those are easier to trace the ancestry of, but also why problems with them are harder to overcome if they are the cause of genetic disease. Now, if you take the factors that are actually relevant, rather than ones chosen to give inaccurate results, but results that are convenient for creationism, then yes, you can calculate about how long you should have to wait to see a series of mutations on average. But of course, the reason creationists use the wrong factors is that it gives them the wrong answer. But an answer that, if correct, would make evolution using mutation as the source for new raw material on which other mechanisms can act implausible. And the thing is that a lot of the creationists who do this know better. They know they're getting absurd results that don't actually map onto known behavior of real populations. They just don't care. Further, this idea directly contradicts the idea of created heterozygosity, in which God has maximally diverse organisms on the ark, and then subsequent diversity is driven primarily by crossover events shuffling this pre-existing diversity up. This would have to make the crossover events extremely likely, but the waiting time problem depends so heavily on it being so rare that they tend to pretend that it doesn't happen at all. So on the one hand, creationists need crossovers all over the place to get modern diversity, but also need them to be vanishingly rare so that mutation seems an implausible mechanism to generate biodiversity. The waiting time problem as described by creationists also falls into the trap of thinking that evolution must proceed linearly toward predefined goals. So they will calculate how long it will take for a specific sequence of mutations to occur and fix one after the other. So if they need mutations A, B, and C, they will assume that only after A occurs and reaches fixation should they expect B. But this is simply not how evolution works. There may be many sequences of mutations that can result in the same benefit. We can see this work in modern organisms who have the same morphological adaptation but different genetic causes. For example, human populations in both Europe and Eastern Asia tend to have pale skin, but for different genetic reasons. Also, Mexican cave fish are all blind, but for different reasons genetically, such that hybrids from different cave populations end up having functioning eyes, because with different eye genes broken in different populations, the cross between them ends up with a full set of functional genes for eyes. Further, the required mutations can occur in separate lineages at any time and can even combine due to crossover before reaching fixation. So creationists are using a series of assumptions we know to be false, then using the wrong parameters and getting results that they set out to get in the first place. This is not how science works. And there's a reason that real geneticists and evolutionary biologists don't even normally bother engaging with creationists. It's the same reason that real law enforcement doesn't bother looking into what kids playing cops and robbers are doing.
And as those calculations are being made, if you get beyond 2 or 3 coordinated mutations, the waiting times just balloon well beyond the time available for the entire history of life on Earth, excepting the great ages that most geologists talk about. So,
weird then how we know of actual mutations which required more coordinated mutations than that have happened in laboratories in decades. Not, trillions of years. Like the CIT+ line of Escherichia coli bacteria in the Lenski long-term evolution experiment. I guess that sucks then. So we know both from theoretical work that creationists are using the wrong math with the wrong assumptions, and we know from a practical standpoint that it just doesn't take that long, because we can watch it happen.
Give them 3.5 billion years. It's not enough time to generate the kind of changes that we see in the history of life using the mutation natural selection mechanism. So that's a big problem.
No.
Now, in my book, I discuss this problem in light of another discovery that makes the problem even more acute. And that is the discovery of the information-bearing properties of the DNA molecule. This discovery came in the 1950s. Watson and Crick, I'm not pressing the right buttons up here, thank you. Watson and Crick elucidate the structure of DNA in 1953. The structure, they realized right from the beginning, suggests that the DNA molecule may have the capacity to store information in a digital form. In 1957, Francis Crick proposes something called the sequence hypothesis, in which he suggests that the chemical subunits along the interior of the DNA molecule are functioning like alphabetic characters in a written language or digital characters in a section of machine code, the zeros and ones in a section of software. Which is to say, it's not the chemical properties of these chemical subunits in DNA that matter. It's not the shape of those subunits. It's their arrangement in accord with a symbol convention or code that allow them to convey instructions for building all the important proteins and protein parts that cells have that keep them alive. I'm competing with myself here. Okay.
I let that go for a long time because, well, nothing he's saying is news to evolutionary biologists or population geneticists. Just explaining how an aspect of modern biology works isn't exactly a slam dunk against modern biology.
So I've got a little piece of animation that I'll just run in the background as I'm describing this, but this has been one of the great discoveries of modern biology. It's a stop-press moment in the history of life. The biologists discover that code is literally running the show inside living systems.
Yeah, so?
Let me give you an analogy.
Who wants to bet it's a bad analogy to some human-made thing that doesn't have the important properties of life, like replication with variation?
And as you can see some of the animation running in the background, it's explaining how, and you can watch this on my website if you're really interested tonight, but the animation is explaining how the digital information in the DNA molecule directs the construction of the protein parts that are so important to keep our cells alive. Proteins perform all the important jobs. They catalyze reactions. They form the structural parts of molecular machines. We have inside cells extraordinary little tiny nanomachines, rotary engines, sliding clamps, turbines. It's just extraordinary. They're typically made of proteins, and the proteins also process information.
Holy crap, dude, get to a point.
So you've got this extraordinary process going on inside the cell, and here's the analogy. Any engineers here in the audience?
Of course there are. The Salem hypothesis strikes again. For those of you who don't know, the Salem hypothesis says that engineers are more likely to become anti-evolutionists because they already tend to see things in terms of intentional design. Because that's the whole point of an engineer, to intentionally design systems.
Okay, some engineers familiar with CAD/CAM, computer-assisted design and engineering. I'm from Seattle. We've got two really famous companies up there, Microsoft, where they write code, Boeing, where they use code to direct the construction of mechanical systems called airplanes.
Well, I guess I won that bet. If it doesn't reproduce with variations in heritability, then it's a bad analogy for evolution. In fact, really, you should try to explain a point before making an analogy in evolution, because analogies are actually mostly pretty bad, and you can't rely on them to teach ideas in biology.
So you've got an engineer sitting at a console. He writes code to specs for producing a particular part. That code is sent down a wire. It's translated into a machine language that can be read at the manufacturing center, and then that manufacturing center will take that information and use it to, say, place rivets on exactly the right place in the airplane wing. So you build the airplane wing according to specs. Information directing the construction of mechanical systems. That's what's going on inside cells. Molecular machines made of proteins. The proteins are built according to the specs, the instructions stored in the DNA molecule. It's a mind-blowing discovery. Now, I call this discovery the DNA enigma.
Of course he does, because it's not at all enigmatic, and because that makes it seem like scientists are just scratching their bums, not being able to figure out anything about how evolution could possibly work.
And the enigma here is not, sorry, let's go, yeah, there we go. It's not what the DNA does. It's not even the structure of the DNA molecule. Watson and Crick solved that for us. The information is, the enigma is, where did the information come from?
From mutations, which literally change the information in DNA. If the information is a sequence of nucleotides, which it is, and mutations are what we call changes in that sequence, which they are, then problem solved.
Okay. And I found in talking to students, nobody talks about that in biology classes. They say, here's what DNA is, here's the structure, here's what it does, but no one raises this deeper question, where did it come from?
I'm going to need a citation for the idea that no one in biology classrooms talks about mutation. That's not been my experience in biology classrooms. Also, I asked Dr. Dan Sturden-Cardinal if he mentions mutations. Oddly enough, it turns out that he does, and he teaches these subjects.
Now, I also used to ask my students the question, if you want to give your computer a new function, what do you have to give it?
Nope, we're not allowing intentionally misleading analogies. We're skipping all this dumb shit about computers until he gets back to biology. Computers do not work like cells. Sorry.
If you want to build a trilobite from whatever simpler form of life was around before, you've got to generate a whole new group of specialized cells. Every new cell type needs dedicated proteins.
Good thing we have seen new proteins develop in historical times, and that we know what mutations have occurred to get them.
If you're a gut cell, for example, if you have a gut in an animal, those cells need enzymes, digestive enzymes to do their job. And those proteins are constructed in accord with the instructions stored on that DNA molecule. So what's this all got to do with the Cambrian explosion?
Presumably that it happened a bunch at the time, which isn't surprising in one of the biggest adaptive radiations in the history of life on Earth.
Well, when we see all these new forms of animal life, we're not just looking at an explosion of new form, of biological form, we're looking at a new explosion, we're looking at an explosion of new information.
Good thing we already know where information in the genome comes from then. In fact, just the idea that Meyer thinks the waiting time problem is relevant to this discussion means that He too thinks that, at least in principle, mutation can create information. He just thinks it happens too slowly. Since we already know he's dead wrong about that, this problem is solved. Basically, his whole enigma is, well, mutation isn't fast enough, so maybe God created new genetic material. Except, it is fast enough. And now he's couching the whole thing in terms more familiar to most people from computing, or perhaps book printing, areas that are not analogous to living organisms and which demonstrably both require and have design. This makes it seem like living things also need design. The whole thing is a dishonesty built on top of a pile of faulty assumptions that then use wrong math. Pro tip, if you're going to try to overturn all of biology, you might want to actually get it right first.
And that's the big question that my book addresses. Where does that information come from?
If this talk is any indication of how good a job he does addressing this question in his book, then Stephen Meyer owes a personal apology to each and every one of the 3 trillion or so trees that exist for crimes against their cousins that he committed in having them felled to make the paper his book was printed on.
Now, there's a couple of, there are many reasons that the neo-Darwinian mechanism, the idea of natural selection acting on random mutations.
We wouldn't want to muddy the water with sexual selection, drift, neutral theory, niche partitioning, etc. Just natural selection and mutation, that's it. The last 160 years of evolutionary biology didn't happen. Seriously, I wonder if Meyer could pass a freshman intro to evolutionary biology course final exam. I doubt it.
Does not explain the origin of that information.
It does, in the word mutation. After that, there's another software analogy.
We don't do that here.
There's a big mathematical problem with the idea that random changes can generate new information. The problem is there's a reason that the random changes tend to degrade information, and that is that there's a lot more ways to arrange characters in any system of any combinatorial system for conveying information. There's a lot more ways, a lot more arrangements that will produce gibberish than there are that will produce meaningful text or functional sequences.
Yeah, but how much more? And how does this apply to DNA? Well, the first thing we can look at is, are there mutations that do nothing? Let's go over genetics 101, like high school level genetics. Now, this is profoundly simplified, but these basics are needed for this discussion. A gene is a unit of DNA that codes for a protein, and it takes the form of a series of codons, starting with a start codon and ending with a stop codon. Each codon consists of 3 nucleotide base pairs. Since only one side of the DNA is read, we can simply use the nucleotide on the side being read, either uracil for RNA or thymine for DNA, then adenine, cytosine, and guanine. Proteins are made of strings of amino acid, and the codons, other than start and stop codons, code for amino acids which are added to a building protein molecule in sequence. Well, in DNA, we have 64 possible codons. Now, of those, we have 2 codons for phenylalanine, 6 for leucine, 3 for isoleucine, 4 for valine, 6 for serine, 4 for proline, 4 for threonine, 4 for alanine, 2 for tyrosine, 2 for histidine, 2 for glutamine, 2 for asparagine, 2 for lysine, 2 for aspartic acid, 2 for glutamic acid, 2 for cysteine, 1 for tryptophan, 6 for arginine, 4 for glycine, 3 for stop, and 1 for start. So already we can see that we only have 21 things a codon can code for, and the only codons that are actually unique are the start codon and the tryptophan codon. So we can already see that a large portion of mutations are actually going to end up being between codons that do the same thing, called synonymous codons. Mutations of this kind have literally no effect on the protein produced. Further, much of DNA exists between genes as simply spacer, and the important thing about that DNA is not its sequence, but that it simply exists, so genes don't run together. This DNA is not what is called sequence-constrained. Sequence-constrained means that the sequence of the DNA is important to the organism and so is subject to selection. Non-sequence-constrained DNA can withstand virtually any mutation other than huge deletions, and the organism can essentially be unaffected. Now, genes are generally sequence-constrained, and so are regulatory regions such as promoters. Now, it's not really worth it to go into detail about exactly how promoter regions work, but they receive chemical signals, and then this activates the genes they promote to create the proteins in question. The structure of promoter regions and genes associated with them is common across life, although bacteria arrange these things very differently. In bacteria, their genes are grouped into what are called operons. An operon contains a set of related genes that all have to do with a single function, such as all the proteins needed to metabolize a particular food source. So if Meyer is right that sequences that do nothing are vastly more likely than those that do something, if we were to take an operon promoter from a bacterium, which happens to be about 100 base pairs long, and replace it with, say, absolute random noise, we should expect virtually no activity of the operon, since that random noise shouldn't be able to produce functional promoters. Well, E. coli bacteria have an operon for digesting lactose, the sugar most common in mammal milk. Now, let's forget the fact that Meyer thinks that bacteria far predate animals, never mind mammals, and there would be no easy way to explain the existence of a lac operon at all when milk evolved billions of years later, according to him, which means that presumably lactose digestive enzymes would also have had to evolve, even though that's apparently impossible, according to him. We're going to forget that. So the operon, like all operons, has a promoter region. And sometime around 2018, a trio of scientists, namely Abihu Agiona, Eric J. Alm, and Jeff Gore, decided to do exactly what I was talking about. They replaced the whole promoter region with random noise in a bunch of bacteria, each getting its own unique bit of random noise. So if Meyer is right, basically none of them should be able to digest lactose. But 10% could, without any mutations, from random noise, some even better than wild type. So out of the 1.6 times 10 to the 60th power possible combinations of 100 base pairs, about 1.6 times 10 to the 59th power are functional as lac operon promoters. And of those random sequences, about 60%, over half of the random sequences, could function as lac operon promoters with only 1 point mutation. When Myers tells you that mutation can't provide function because there are so many ways for DNA to do nothing and so few ways for it to do something useful, he is ignoring that there are so many ways for it to do a given function that if we allow for one mutation, they fill up a significant portion of the sequence space available. If totally random noise can do that, then it should be no wonder that when starting with already well-ordered genes with specific functions, random mutations can and do provide new functions fairly easily, and without any particular need for a divine hand.
Just quick illustration. Turns out this is a bizarre thing, but if you take just a 12-letter word in the English language,
which has far more than 4 letters, arranged into morphemes that are often far more than 3 letters long, so, bad analogies for codons, and the majority of letter combinations do not form morphemes, so again, this is a bad analogy for codons, and I suspect an intentionally bad one. We already know that this is a bad analogy for DNA from the experiment we just talked about. We're still not doing analogies that don't apply.
Here's a familiar combinatorial system. It's called a bike lock, okay? It's got 4 dials, and each dial has 10 digits on it. So how many different ways are there to arrange the characters on the lock? 40, right? 10 plus 10 plus 10? What? Trick question, right? Okay. It's 10 times 10 times 10 times 10. There's 10,000 possibilities.
Thanks for the high school math problem, Steve.
Which is why a bike lock works, okay? If you imagine we've got a thief out there outside the school, sees a nice new bicycle that he'd very much like to have, but he encounters an impediment to his avarice, the lock, okay? Question, if he encounters a lock with 4 dials like this, is it more likely that he'll succeed in opening the lock or that he will fail to open the lock? Another trick question. Okay, our intuition is, yeah, fail, because we're thinking he probably isn't going to stay at this very long, right? But it does depend, can you see it does depend on how much time he has? I've made some stupid calculations that show if every 10 seconds you get 1 new combination, it will take you about 15 hours to search more than 5,000.
But let's compare this to DNA and use the actual experimental evidence of about 10% functionality. And just to be nice, we'll pretend that the 60% of sequences that are 1 mutation away from function don't exist. Now the thief only has to check 500 sequences to get to that 50% chance of unlocking the bike. So he now has a 50% chance of getting it in 1 hour, 23 minutes, 20 seconds, trying 1 combination every 10 seconds. Now let's say that he's not the only one trying. There are 1 million people trying to unlock the identical locks. This is to represent a very small population, since this is an analogy to evolution here, and that's a population level phenomenon. Well, now we're virtually guaranteed to get it on the first try, and the average length of time it will take to get the right answer is 5 milliseconds. Or, 10 seconds, since that's our minimum time. Funny how this doesn't seem like a big barrier anymore.
Once you get to 5001, it becomes more likely than not that you'll succeed than it is that you will fail. So if we grant that our thief has 15 hours, then the answer to the question is, well, yeah, it is more likely that a random search will eventually generate the combination and he'll be able to open the lock. All right.
Yup, and it becomes trivial when you make assumptions more analogous to DNA.
But what if our thief, this is our thief out there, randomly searching, but what if, instead of a 4-dial lock, he encounters one like this? Okay. Oh, thank you. That's the random search, and here's now the other lock he encounters. Okay. Now what? What's the situation now?
Well, let's see, we have 10 billion combinations, of which 1 billion or so should work, so we have to search 9 billion combinations with that same population of a million or so. So that means that every 10 seconds we search 1 million combinations, and we need to search 4.5 billion combinations to have a 50-50% chance at solving the lock. Now, I know this isn't actually how you do this math problem. Stick with me, because in this section I'm being extremely nice to the point of doing math wrong in Meyer's favor. I'm going to here pretend that it actually matters how big the length of the sequence is, which would be true only if one sequence worked. But since that's not the case in DNA, it actually only matters what the functional fraction of possible sequences in the sequence space of that length is. For example, if 1 in every 10 sequences of any given length are actually viable, then to have a 50-50 chance of getting a viable solution, you actually only have to try 5 times, no matter how long the sequence is. But we're going to set that aside and just continue to say the sequence length is the important thing. So if we search for a functional combination using Meyer's stupid math from 9 billion functional sequences, that means we need 4.5 cycles or 45 seconds to unlock the lock. I'm not seeing the problem here. And now you might say, but the problem of variable sequences is probably lower for sequences above 100 base pairs. Okay, sure. Let's drop it down a couple orders of magnitude. We're still at 1 hour and 50 minutes to get a viable solution. Again, using Meyer's stupid math. We're actually at basically 50 seconds, so it doesn't really matter. But still, even with his stupid math, 1 hour and 15 minutes. Now, we could get way more complicated than this and look into the chances that different people on different random walks encounter the same random sequence and whatnot, but I think you see my point. DNA doesn't have a single functional sequence, it has many, and we are trying many times to get the right answer. So it really isn't that big of a deal.
Is it more likely that the thief will generate the information he needs to open the lock in the time available to him? Well, let's give him his whole life. Now, I've made calculations on this as well, and it turns out that, that if he lives 100 years and does nothing but sample combinations, he's only going to sample about 3% of the total, okay?
So he's got a 30% chance or so of getting it right. But let's be nice again and toss away a couple orders of magnitude and say he's got a 3 out of 1,000 chance. So yeah, he's probably not going to get it. But there are a lot more than 1,000 thieves out there, so chances that someone gets it are pretty good.
So this is, first of all, a bad way to spend a life. And secondly, it becomes, can you see that in this case, with all the time available, it's going to be overwhelmingly more likely that he will fail than it is that he will succeed.
Any given individual, yes. But evolution happens to populations. We're not waiting for a single individual in particular to have a particular mutation. We're waiting for any of them in a large population to have any of a large number of possible functional mutations. That's going to drop the problem down, as we've seen, to basically no problem at all.
Which means if you're a betting person and you form a hypothesis about what's the likely outcome of such a random search, the hypothesis that he will succeed is overwhelmingly more likely to be false than true.
Okay, but what if I bet that someone will succeed, and I have a lot of people doing this, and about 0.1% of combinations work? Well, then suddenly it's a great bet. Now, of course, in all of this, we're still ignoring the fact that if any percent of possible combinations work, then really the correct way to calculate this is half as many attempts out of 100. So if 10% work, it really only takes 5 tries on average. And if only 0.1% work, then it only takes 500 tries. You can see how I'm being absurdly generous and it still doesn't cause a problem. That means that no matter how big the lock is, what matters is what percentage of combinations will unlock the lock. And we know it's more than just one combination. In fact, we know it's a lot more. His entire shtick depends on there being only one person making these combinations and only one of them being right. Both are stupid assumptions.
Can you see that? There's a connection to the truth or falsity of the chance hypothesis. Now, the question that I pose in the book is this. If we think of a gene or a protein as a combinatorial system, remember that picture of the DNA molecule that I had up there and had all the A's, C's, G's, and T's? Well, you can see that there'd be a whole bunch of different ways of combining those A's, C's, G's, and T's. And those are going to correspond to a whole bunch of different ways of combining what are called amino acids, which make up they're the subunits of the proteins that the DNA codes for. So what you're dealing with in biology are actually combinatorial systems.
But as we've seen, all 64 codons have meaning, so we're probably looking at a much higher than 0.1% of sequences having some function. See, that's the disanalogy with bike locks. The point of a bike lock is that only one combination works. Honestly, his analogy is just as dumb as the computer code, but I wanted to say that the minute you make even remotely realistic assumptions, no matter how you do the math, the dumb way or the real way, it just doesn't work the way Meyer wants it to. And yes, I intentionally sat down and did math wrong just to be generous to him and keep with his assumption that sequence length and not fraction of sequences that are functional was the important metric.
There's lots of different ways to arrange the characters in the DNA, only a very few of which are going to yield a functional protein.
But what proportion is that, Steve? He won't tell us because he knows it's a lot more than one. In fact, many combinations can result in the same proteins, and for any one function, more than one protein can do the job. That's why different organisms use different proteins for the same function. This whole bike lock thing is stupid, and I suspect Meyer knows it.
And the question is, in the case of life, is it more like the first case, where with enough time, the thief could conceivably open the lock, where he'd get to a better than 50-50 chance of doing so? Or is it more like the second case with a 10-dial lock?
Well, since both cases are essentially the same, and we know that if you make it even somewhat analogous to actual life, both problems are completely trivial, I'd say that we have a nearly 100% chance that life can stumble on functional proteins with a random walk.
And I simplify here, and there's a lot about this in my book, but here's the situation mathematically. That's the search of our... if we're looking at just one gene with the information for building one new protein...
And remember, there is more than one gene sequence that can build a single protein, and more than one protein that can do a particular job.
The ratio of the sequences that will produce a functional protein to all the gibberish sequences is about 1 over 10 to the 77th power. This has been experimentally determined.
Really? Because actual experiments in random DNA noise seem to get more like 1 over 10. Weird. It looks to me like he's calculated the chance of a string of DNA getting a particular sequence of a given length, even though more than one of such strings can perform that function. Seems Steve here doesn't know what to put into his numerator. Oopsie.
For a very short gene and protein sequence. Okay? Now,
again, the length of the sequence isn't the important part. It's the fraction of such sequences that give a viable sequence. And it's more than 1 over sequence length. Now, I'll grant you that longer sequences would probably have lower proportions of functional sequences, but it's never going to simply be 1 over sequence length as the fraction of sequences that are functional.
There's only 10 to the 65th atoms in the entire galaxy.
Oh, we're doing the big numbers thing. Now, we're going to skip that. No matter how big you make your number that you made up to pretend that evolution doesn't work, it won't be a problem for evolution.
All right, so this is a big space to search, a big haystack looking for one little needle, okay?
But Steve, you know it's not one needle, don't you? And of course, you know that some of those bits you're searching in are needles for other function, and that the subset of functions an organism has managed to acquire versus the number of possible functions it could hit on is never going to just be 1. It's always going to be less than that.
But it turns out that there's only 10 to the 40th organisms in the entire, we're searching our 10 to the 77 possibilities. It turns out that 3.5 billion years is not nearly enough time to search this effectively.
Well, let's see. 10 to the 40th organisms, but that have ever lived, I presume. Let's be more reasonable and say it's 1 billion across the whole planet. And let's say that this is an important sequence that we really need in organisms, so we only have like 1 million years. And we're trying a combination per second. So there are 31,557,600 seconds in a year, roughly. That would mean that we're getting 31,557,600 billion attempts per year, which also means that over 1 million years, we're doing 31,557,600 quadrillion attempts, or 3.16 times 10 to the 23rd power. Now, that's assuming only 1 billion organisms. That's probably not true. It's probably much closer to a very high number, but we're being generous, remember. Now, that's still way less than the 10 to the 77th power, but we already know that that number is nonsense from the Lac-Operon experiment. So what we have, really, is that with these fairly conservative numbers, we have a reasonable chance of stumbling across a protein if the actual fraction of function is somewhere around 1 in 10 to the 24th power. And the thing is, we have good reason to think that it might be well closer to 1 in 10 to the first. You know, based on that experiment that I bothered to cite, unlike this mysterious experiment of Meyer's. Now, I probably think it's not actually that high for most long strings of DNA, but it's not going to be as low as 1 in 10 to the 24th. You have to get to about 42 base pairs to even have so many options that only one of them being viable would get you to a fraction as low as 1 in 10 to the 24th. Also, curiously, 128 base pairs gives you a chance of stumbling across any particular base pair sequence of about 1 in 10 to the 77th. So I know that Meyer here is known to be factually inaccurate about nearly everything, and that he didn't bother to cite which experiment gave him these numbers, that he says are experimentally determined. But anytime I see a power of 2 raised to a power of 2, I get suspicious. It's the kind of thing you do to make your experiment easy for a computer to run the math on, not the kind of thing you usually get just running an experiment. I think that the experiment that determined this was that of a mathematician and not one that actually involved DNA of actual organisms. So, Dapper from the future here, I thought this was so suspicious that I asked my science friends about it. Turns out I was mostly right. The number of 10 to the 77th power comes from Douglas Axe, another Discovery Institute fraud. I was wrong that he's a mathematician, but right that it was just a mathematical thought experiment. He assumed that, given a functional sequence, any change to the amino acid sequence would remove that function. And so his number isn't even pretending to be the chances of finding a sequence with function. But the problem is that it also isn't the case that only one sequence of a given length can perform a specific function. Now, he was using amino acid sequences and not nucleotide sequences, but it works out the same way either way, so that's irrelevant. So since I'm on sort of a hemoglobin kick while I'm writing this, if Axe is correct, then when I look for natural variation in hemoglobin in humans, there should be literally 0. Instead, when looking on Google Scholar, the first paper I had reported over 1,000 known variants in humans. I'm sure some of these are less effective than others, but they're all transporting oxygen. So Meyer is misrepresenting Axe's work, which itself is already known to be false, by the simple observation of the fact that protein families exist with variable amino acid sequences, which all do the same function.
Because there's only been 10 to the 40th organisms in the whole history of life on Earth, which means that if every organism in the entire history of life, every time it replicated itself, was generating a new sequence of DNA, you'd still only search 1/10 trillionth of the possibilities.
Yeah, if we took his word for it that the very suspicious number that was determined by some experiment, somewhere, by someone using some unknown method is a valid number, I have no reason to do that, and some good reasons not to.
Okay, 1/10 trillionth. Yeah, that's right. Which means it's overwhelmingly more likely that a search for a new gene, that's a new stretch of genetic information, randomly like that, it's overwhelmingly more likely that such a search will fail than it will succeed, which means that the hypothesis that such a search did succeed is overwhelmingly more likely to be false than true.
A priori, that does seem to be the case. But then, biologists checked. Turns out that a very high fraction of random sequences have function, and more than half are within one mutation of having function. So, seems like we're doing pretty well on this front. And remember, a new functional sequence doesn't have to start out functioning very well. Once it functions at all, natural selection can take over to refine that function. So it's not like to get oxygen transport for some little worm, we need the full complexity of human hemoglobin. Any old protein that transports oxygen better than just diffusion is a boost to that worm's metabolism.
Which means that the neo-Darwinian mechanism is not a plausible means of generating new genetic information. Are people following roughly? Okay, kind of liken this to the 2 bike lock cases. This is like the 10 dial lock.
Again, we get the bad analogy. That implies there is only ever one combination that will work, when we know for sure that's not how DNA works.
And we're giving the evolutionary process essentially its whole life to look, the whole history of life on Earth. And it's not enough time to search the spaces, and so it's going to be more likely than not. Now, anyone seen this film? I think it was called Dumb and Dumber. It had a comic called Jim Carrey. He's kind of a goofy guy, and he sees across the room a lady that he fancies. And so he goes up to her, and he kind of goes, and he has a pickup line, and he says, what are the odds that a girl like me and a guy like you could get together? And he botches his pickup line right from the beginning because he's actually the guy, And she says, not good.
Yeah, it's the 1 in a million line. Later, when he learns she's married, he asks, what was all that 1 in a million talk? Haha, we get it. moving on.
Just because there's a finite probability of something having happened doesn't mean it happened that way.
That's true.
What you need to know is how many opportunities were there for that thing to happen, so you can make an assessment of the kind I just made to determine whether the chance hypothesis is more likely to have been false than true.
Yes, it is important to note that at a basic level what he's doing is reasonable. If something is supposed to have happened in a stochastic manner, then if you can figure the odds, it's a decent way to see if the idea is plausible. But implausible things happen all the time. For example, a woman in 2009 managed to roll 154 consecutive rolls of 2 6-sided dice without rolling a 7. That has a probability of less than 1 in 10 to the 12th. Now, here's a link to a discussion about humans doing improbable things from a much bigger YouTube channel. Also, it's about Minecraft, so, lots of people like Minecraft. Now, if you found another person claiming to have done the same thing, say 1,000 times, that is so unlikely that it would be unreasonable to believe the claim. So while trying to figure out prior possibilities is a valid thing to do in some cases, when you start with nonsense numbers like Meyer does, well, you get nonsense conclusions.
What I've just shown is that the chance hypothesis for the origin of information is more likely to be false than true.
Yeah, it's only his straw man that he falsified.
Which means it's a bad hypothesis, and in science we want to infer to the best explanation, and if something's overwhelmingly more likely to be false than true, we're going to be most likely wanting to reject that, okay, and move on. And that's essentially what's happening in evolutionary biology today. And I tell this story in the book. There are many leading secular evolutionary biologists today.
I really want to know what he means by secular. Technically, it just means that the biologists in question are neither clergy, monastics, nor lay people directly employed by a religious body. Does he mean non-religious? Well, then he should have said that, as it means something else than secular. I ask because many of the evolutionary biologists he would complain about are in fact theists of one stripe or another, including Christians. In some cases, fairly theologically conservative ones.
Who are now saying neo-Darwinism, the standard textbook theory of evolution, it does a good job of explaining small-scale variation. It doesn't do a good job of explaining the big changes in the history of life, the origin of new information, the origin of the new body plans that arise in events like the history of life.
It's just a lie to say that that's a big controversy in evolutionary biology. How these things come about is actually fairly well understood down to the level of which mutations in which genes are probably responsible for what Meyer would call a difference in body plan. I'm with Todd Wood on this one. There simply is no crisis in evolutionary biology. What there are open questions. Many
new theories of evolution are now being proposed because of the problem that I've described tonight about the origin of information and other similar problems having to do with the origin of the big body plans as well. It turns out that's even a bigger problem, and I discuss those in the book. So I'm not aware of any new theories being proposed, although new hypotheses within the theory of evolution are proposed all the time, and some gain acceptance, like endosymbiosis. I wonder if Stevie will give us any examples of these new theories. There's a kind of an odd thing going on in the Christian world right now. You have a big push to get Christians to accept Darwinian evolution. No, not Darwinian evolution. Evolution as it is currently understood, and it's not odd. It's that Christians, like all people, shouldn't be denying obvious reality in order to cling to demonstrably incorrect beliefs. If you want Christianity to have a future, you should probably look for a way for it to not be obviously and demonstrably wrong, even if that means adapting your theology. Like churches had to when it was realized that geocentrism was simply not defensible. It's an idea called evolutionary creation or theistic evolution, and I find it really odd because you have all these leading secular evolutionary biologists in the mainstream of the discipline saying, we need a new theory.
No.
And to attest to that in my book, I described 6 or 7 of the new theories. And some of these theories have advantages over old-fashioned neo-Darwinism, but I also found in describing these new theories that they too fail to explain the origin of the information necessary to produce, say, these big Cambrian animals. No new theory is needed to explain that. It's literally just mutation, drift, and selection. One theory, for example, I really like is called natural genetic engineering. It's been proposed by a biologist at the University of Chicago named Jim Shapiro. Shapiro shows that a lot of the mutations that evolutionary biologists describe are not random at all. They're being directed towards certain outcomes. He says they're under algorithmic control. There's a kind of pre-programmed adaptive capacity so that when organisms respond to certain kind of stresses, they are capable of responding and generating the production of new genes or proteins as needed.
Whoops, that's already been falsified. And here's the thing, it was falsified almost 80 years ago in 1943 in a Nobel Prize-winning experiment by Max Delbruck and Salvador Luria. So if organisms respond to environmental pressures by inducing specific mutations, or even specific types of mutations, there are predictions we could make and check to see if this is the case. I will go through a simplified explanation of the Luria-Delbruck experiment. The idea is as follows. If bacteria mutate to gain resistance to antibiotics in response to the presence of antibiotics, then you take a large number of bacterial colonies and separately expose them all to the same levels of the same antibiotic, and you should get similar amounts of resistance developing in all of them, since all are going to induce about the same mutations in about the same time frame in response to the same environmental stimulus. If, however, mutation simply occurs stochastically and not in response to this, then some starting colonies will start already having a level of resistance, some will only have that mutation late in the experiment and have only limited resistance, and some may never get such a mutation and show essentially no resistance. In other words, if this stimulus-response model of mutation is correct, all bacterial colonies will fall within a narrow range of resistance. And if it is incorrect and random mutation plus selection is correct, there should be a wide range of levels of resistance between colonies. Well, turns out there is a wide range of levels in resistance, so there you go. The idea is falsified. Here's a link to a video Dr. Dan did on the same basic idea, and in the description you'll find the Wikipedia article, because frankly, if your idea was falsified experimentally 80 years ago, I don't feel much need to go past that as a source that I provide. Once something has been known for an amount of time that I could round to a positive number in terms of centuries, there's really no excuse for getting it wrong while presenting yourself as an expert.
But there's a pre-programmed capacity there. And Shapiro describes these non-random evolutionary processes, but he doesn't attempt to explain where the pre-programming came from.
It came from nowhere because it isn't a real thing.
And that's what really interests us, those of us who are proponents of intelligent design. Now, I first got interested in this idea of intelligent design back in the mid-1980s. As Mark mentioned, I worked for an oil company. I was doing digital signal processing. It was an early form of information technology. And I had the chance to meet a scientist named Charles Thaxton, who was one of the first pioneers in proposing this idea of intelligent design. He'd written a book called The Mystery of Life's Origin. And he had become fascinated with the same question I've been talking about tonight. Where does the information come from necessary to produce the first cell? Where does it come from to produce the first animals? And he suggested in an epilogue to this very important book that maybe when we're talking about the problem of the origin of information, we're not talking about something that's going to be solved by materialistic evolutionary processes, because what we know from experience is that information comes from a mind.
Is that what we know? So what is information? Well, the only way we can quantify it is that it's a signal of some kind in which different states for each packet of the signal can exist. In the example of DNA, each nucleotide is a packet of information and it can have 4 states, so it's a 2-bit code. That means you can encode each nucleotide with 2 binary digits. The options are 00, 01, 10, and 11. But there are other things that can carry information. Each photon from the sun carries information. It's a packet, and the energy levels of the photons are the states that they can take. Information in this way manifestly does derive from non-intelligent agents all the time. In fact, I don't think it's a stretch to say that most information arises without any obvious intelligence to create it. Now, if Meyer wants to argue with this, he'll need to give a definition of information that isn't special pleading, isn't this one, and also can result in quantifiable and measurable values, such that we can tell if new information is actually needed to accomplish some biological function. Because otherwise, he's simply wrong that information needs a mind in order to come into existence.
And for him, there was this kind of intuitive connection between mind and information.
Intuition tells you that the Earth is flat, the speed of light is infinite, and that heavy things fall faster than small things, none of which is true. Intuition has no strong correlation to how the world actually works. In fact, it's quite likely to lead you astray.
And he said, maybe what we're looking at is evidence of an intelligent cause. Well, in 1985, I had a chance to get to know Thaxton. He mentored me for about a year before I went off to grad school. And when I went off, I was pretty intrigued with his ideas, but not totally convinced yet. And I had a burning question in my mind, and that was, could this idea that information is pointing to intelligence, Could that be formalized as a rigorous scientific hypothesis?
I think it probably could be, but somehow I doubt that Meyer did so properly. I mean, he still hasn't even bothered to define his terms.
Now, ironically, I ended up reading a lot of the works of Charles Darwin to get to the bottom of this question.
Why? Why would anyone think that looking at the works of a man from 150 years ago, before we even knew how Mendelian genetics works, never mind actually having discovered how DNA works, give you any insight onto how new genetic traits come about? It's like reading Benjamin Franklin's letters about electricity so you can figure out how to program a computer. It's a beyond stupid thing to do.
In part, this is my mentor, Charles Thaxton, and another Charles Darwin, and I was interested in his biological arguments and so forth, but I was also interested in his method of reasoning.
Time to remind everyone that Charles Darwin isn't a prophet. He wasn't the Pope of science, and his words aren't scripture. At this point, he only matters to history, not science. Now granted, it's the history of science, but still no one is basing their current ideas on Darwin. Rather, it's on the basis of data gathered, most of it long after his death.
Because he had pioneered a particular kind of scientific reasoning that was more forensic in style. He was reasoning from effects, all the clues we have in front of us, back to their causes in the ancient past. And it became clear from reading Darwin that there was a special method of scientific reasoning. You couldn't make trilobites reappear in the laboratory. They originated only once. So if you were trying to figure out what caused an event in the remote past to happen, you had to use this more historical style of reasoning that Darwin had pioneered. And scientists and philosophers now call that method the method of multiple competing hypotheses, or sometimes the method of inference to the best explanation. But that raised a really interesting question. What does it mean to be a best explanation?
I'm going to go out on a limb and say that the best explanation needs to be the one with the fewest otherwise unwarranted and unevidenced assumptions, and that explains the widest range of data, while still being both falsifiable and so far unfalsified despite opportunities for falsification.
Well, Darwin had a principle, and he got it from his mentor, another Charles Lyell, one of the great geologists of the 19th century. And Charles Lyell's idea was that if you're trying to reconstruct what happened in the remote past, you want to choose that hypothesis. The best hypothesis or explanation is the one that cites a cause that is now in operation. That is, in other words, a cause that's in our uniform and repeated experience is producing the effect in question.
Imagine that. I see something happening now with consistently the same cause, and then I suppose that's probably what caused it in the past. And remember, if we have a problem with that, it's basically impossible to ever solve a crime with no witnesses. Because this assumption is basically the bedrock of science. That laws of nature aren't changing all the time, rather they're consistent across time and space. This is the basis not only for all science, but also specifically for the forensic science, that I hope Meyer would place his trust in if, God forbid, someone close to him were the victim of a crime that left no witnesses.
And when I came across those words on the title page of his book, Causes, by reference to causes now in operation, a light went on for me. And I began to think about the problem of the origin of information. I asked myself a question: what is the cause now in operation that produces digital code?
Did you notice the bait and switch there? He starts out asking about information and then switches to digital code, which he's already primed his audience to equate with computer code. It's slimy, dishonest, and I hate it.
What do we know from our uniform and repeated experience about the origin of digital code?
Sometimes it comes from humans, and sometimes it comes about without humans, such as in the case of mutations in DNA, which, as we already discussed, is a 2-bit code.
Soon after, I encountered another author who was writing about he was applying the information sciences to analyzing the information in DNA. And he made an offhand comment: the creation of new information is habitually associated, he said, in our uniform and repeated experience, with conscious and rational activity.
Yeah, but he didn't say our uniform and repeated experience. He said habitually, which means usually, but not always. If I habitually drink 2 cups of coffee in the morning, it means that there are days when I drink more or less. Otherwise, it's not just a habit, it's a constant. If I would say that I always drink 2 cups of coffee, that would constitute a uniform experience. So basically, Steve is just lying about this quote and doing so openly and brazenly. There isn't even a point of me looking up the context, which probably wouldn't help his case, since he's not even reporting the part that he cherry-picked and put up on screen accurately.
What do we know from our experience that produces digital information? Well, minds, intelligent agents.
And random mutation, yes, go on.
And Bill Gates has sort of intimated something like this when he says the DNA is like a computer program, only much more complex than any we've ever devised.
Non-biologist has hot take comparing biology to the thing he knows about isn't exactly a newsworthy or significant thing.
I think that's a very interesting statement, because if you think about the implications,
you realize there are none, because DNA doesn't work anything like a computer code. It doesn't arise the way computer code does, and we know how variations originate, because we watch them happen in real time, and it doesn't look like someone writing code.
Intelligent agents. That's what we know from experience. That's the one cause of which we know that generates information. And I thought, that's very significant, because as I thought about it, it's not just the code in software, it's any place we encounter information in a digital or alphabetic form, whether it's in a hieroglyphic inscription or a paragraph in a book.
Or the emission spectrum of a hot cloud of gas in space. Oh, wait, right, Meyer's completely wrong and comparing apples and oranges.
Or a section of code in a radio signal, or embedded information in a radio signal. Whenever we find information and we trace it back to its source, we always come to a mind, not a material process.
Except in all those cases when we don't. Unless, like I've said, Meyer wants to bother to define information in some non-standard but still useful way. He hasn't, so I can't do anything but use the normal definition.
And so I've argued in my two books, Darwin's Doubt, which concerns the origin of animals, and let's go back here, and Signature in the Cell, that the origin of information that we see arising in the history of life is best explained by a designing intelligence.
It's true, he has argued that, I'll give him that. Now, no one outside of some religiously motivated pseudoscience and laypeople have found it convincing, but those books were at least an attempt.
And the ironic, somewhat mischievous approach I take is to use Darwin's own method of reasoning to make that case. I come to a different conclusion. Darwin wanted to deny that there was actual evidence of design in nature.
Or did he just find that that's where the evidence led him?
But I'm arguing that based on what we now know, in particular what we know about the digital information stored in DNA, and I've really only given you just a little bit of the story, because it turns out in addition to digital code in DNA, we have networks of genes that function like integrated circuits. They're called developmental gene regulatory networks, and you can read about them and what they do.
One of the things they do is put the lie to the entire premise of Darwin's Doubt. So yes, by all means, everyone, go read about them.
In my book, we also know that the information in DNA is only part of the information that's necessary to build a whole animal form, that there's a hierarchically organized information processing system that's kind of like, say, the information that we've got information that is necessary to build a circuit board, more information necessary to build the computer. The computer can be linked into a hierarchy of networks. We organize information in hierarchies, and biological systems are hierarchically organized information processing systems, suggesting again
that we uniformly see unguided mutation coupled with drift and selection in nature originating the information we see coming into existence. That since we uniformly see unguided mutation coupled with drift and selection in nature originating the information we see coming into existence, that according to Meyer's own rules, that there is no particular need for an intelligent designer in biology, even if in a separate, largely unrelated set of circumstances, we see intelligent designers designing other things.
So I think the case for intelligent design can be made very powerfully at many levels.
Odd that it hasn't been then.
Now, in close, some of you may wonder how the argument I've made about intelligent design is the best explanation for the origin of the information needed to build these new animal forms in the Cambrian period, how that argument has been received in the scientific community.
Yes, how has it been received by the people best able to assess the arguments contained in it? That's an excellent question. What is the consensus of the experts in the field?
The book came out in 2013. It was reviewed initially quite frivolously in a number of sources.
So the initial reaction of experts was that the book was so bad that it was more of a joke than a serious attempt at scholarship.
But then in the fall of 2013, there was a very serious review in the journal Science, written by the distinguished paleontologist and evolutionary biologist at Berkeley named Charles Marshall. And Marshall wrote a respectful review. He said some nice things about the book, but on the crucial argument, he said he begged to differ.
So finally, an expert bothered to condescend to give it a more thorough treatment than other experts, probably more than it even deserved, and came away saying the book fails to make its case. Yeah, this is really not going well for Stevie Boy. And
his claim was this. He says that Meyer argues that you I'll paraphrase, but he says, Meyer argues you need all this new information to build the Cambrian animals. He says that's not our current understanding. Our current understanding is that all that you would need to have is these gene regulatory networks, the evolutionary process would need to rewire these networks of genes to control the expression of other genes for building the different parts of the animals. And when I saw that passage in his review,
he realized that essentially 100% of the experts thought that his book was basically a joke, and the one guy who didn't came to the same conclusion that I, a layperson, immediately did. That Meyer doesn't know what he's talking about, and that the problem he thinks exists hasn't been considered a problem for quite some time.
Because this was the best possible critique I thought that I could receive. Not because it was correct, but rather because it revealed the weakness in the position of the other side. A network of genes contains what? Genetic information, and lots of it, okay?
Sure does. Too bad nothing has been done to show why that's a problem.
And the networks of genes that act on other genes for building the parts of the animals, what do those other genes contain? More information. Rewiring a network of genes requires multiple coordinated changes in code. More information. So to explain the origin of the information necessary to build the Cambrian animals, this leading evolutionary biologist begged the question.
If that's Meyer's takeaway, then I can only conclude that he has no self-awareness whatsoever. His amazing work that will overturn one of the most well-supported theories in all of science was met with dismal and near-universal mockery. There has been no reversal of that state since, and his triumphant comeback is that if he doesn't bother to define information, he can pretend that it can't come about naturally. This is honestly pathetic.
He simply pushed the question back and said, well, it's in the information that was there prior to the building of the animals or something, okay?
Yes, he did push back the question, but luckily that's a question that's been answered. And in doing so, it also shows the main thesis that Meyer has in his book, that the phyla were specifically created because we have no explanation for how their ill-defined body plans came about apart from magic, is simply incorrect. Even if it were the case that genetic information needed to come from a mind, that still means that Meyer's thesis is definitively wrong, and he needs to try again.
But he didn't explain the origin of information in the first place. How you solve, for example, that combinatorial problem that I was explaining earlier with the bike locks.
The one where he dishonestly pretended that only one sequence can possibly have any function out of a sequence space? Right, that one. The one that's been shown to be wrong on the basis of just regular math, but also experiment?
Okay, so I actually think that we're at a place of real impasse in evolutionary theory. The crucial questions are either not being addressed, like the natural genetic engineering, really good description of some really real processes.
Yeah, we really are at an impasse about the idea that was disproved longer ago than most of my audience have been alive. And by like 3 or 4 decades in most cases, if my YouTube analytics are to be believed.
But it doesn't address the deeper question of where the programming comes from. And Marshall's response is of the same kind. He just pushes the question back.
The question that was already answered. Okay. After this is a Q&A session, and I'm going to cut out applause and some logistics of setting that up.
Yeah.
No, I was wondering what your personal view is where that intelligence comes from. Are you a believer in?
I'm a theist. I believe the intelligent designer is God, and I'm also a Christian. Yes, right.
In my book, there's nothing wrong with being a Christian, but I do think that this and the Wedge document show that this isn't about science. It's about religion, and the pretenses to scientific objectivity and rigor are just a smokescreen to hide a political agenda to enforce Christian hegemony, if not outright theocracy. The follow-up is about young Earth creationism and how Meyer theologically interprets the 7 days of creation with his old Earth beliefs. I don't care about that, so I'm not going to play his answer.
My question really is more for the neo-Darwinists, but I'm curious just your involvement with them.
I think I count as a big, scary neo-Darwinist, so I'll answer that question too, I think.
You know, when the lack of transitional forms was acknowledged, they came up with punctuated equilibrium.
That's a gross oversimplification. It's not that there are no transitional forms, it's that while transitional forms between major groups of organisms are abundant, those between closely related species are less common.
When they find animals with similar traits, even if the genetic level that are not related, they say convergent evolution.
Generally, no. Convergent evolution results in traits with similar function but very different form. That's why the anatomy of a trout fin and a whale fin are very different, or the anatomy of an insect wing is radically different from that of a hummingbird wing, or why the hemocyanin of a horseshoe crab is very different from the hemoglobin of a human. And these differences are also reflected at the genetic level. For example, at the level of amino acid sequence, bats and toothed whales make an identical protein called prestin. It's involved in echolocation. But at the genetic level, there are basically no more similarities than required to make the same protein. They use different codons to make the same amino acids, specifically because the protein was convergently evolved.
My question is, every time there's a discovery that should falsify evolution, they change the definition of what evolution is.
That has literally never happened.
So the way they've set up this theory, it's by definition not falsifiable. So is it a scientific theory? I thought a scientific theory had to be able to be falsified.
It does have to be falsifiable, and evolution is. For example, if we could show that a lineage underwent maladaptive stages as a means of getting to a better adapted outcome in the long run, therefore showing foresight in their lineage's evolution, that would falsify most of the current theory. If the neutral variation in organisms that should otherwise be closely related didn't fall into the same nested hierarchy as their non-neutral variation or morphology, that would falsify common descent. If organisms were more or less randomly sorted in the geological column, that would falsify it. So it is falsifiable, and it is based on observation and experiment. So yes, it meets all the criteria to be a scientific theory. Now let's see how Steve responds.
I'm going to be a little contrarian here as well, but I get the spirit. I agree with the spirit of the question. There's a fine point in the philosophy of science about how do you define a scientific theory. And it turns out it's super hard to do that. It's something called the demarcation question. And a lot of my work was showing that however you define science, that intelligent design is every bit as much a scientific theory as Darwinian theory is. You can apply different yardsticks.
Except for the part where, since this designer, according to most intelligent design proponents, or to give them the term they apply to themselves, see design proponentists, treat this designer as omnipotent, it's clearly unfalsifiable in every way, unlike evolution. There's also no positive evidence for it, and everything it purports to explain is explained in a way that produces no useful predictions and requires more otherwise unwarranted assumptions than evolution. I'm going to go ahead and say that it in no way is as much a scientific theory as evolution is.
And people choose different yardsticks. And this one you're talking about, falsification, came out of the philosophy of science of a guy named Karl Popper. And there are problems with it because it doesn't capture the comparative nature of scientific testing. It says you can just make predictions, and if the predictions don't come true, if the predictions don't come true, well then you're obligated to reject your theory and say it's false. Okay.
At which point you can come up with a modification of the hypothesis. It's not like you have to start from scratch if 1 out of 5 of your predictions didn't match up. Falsification doesn't have to be an all or nothing proposition. And of course, falsificationism isn't the be all and end all of science, but if you can't know that you're wrong, it's going to be hard to convince the scientific community that your ideas are plausible or scientific.
But scientists all the time have lots of reasons why they think a prediction might have failed other than their theory being wrong. And sometimes it's an okay thing to think, well, maybe there was a disruption in the conditions under which the experiment was performed, or so.
But that's a problem with experimental design, not falsification. Basically, the scientists are wondering if the experiment actually falsified the hypothesis because there may be unaccounted for variables. That doesn't mean we don't have to worry about whether or not a hypothesis can, in principle, be falsified.
And they call those, they'll come up with auxiliary hypotheses. Well, the theory was right, but this other thing was the problem. And it's a judgment call, ultimately, as to when you've added too many of those in an implausible way to save a theory, all right?
Oh no, like nearly everything else in human existence, there are continuum problems in science. Better just explain it all by miracle, I guess.
I think a better idea about what constitutes science, a better description of the way science works is this method I call inference to the best explanation, where we're really testing things by comparing explanatory power and predictive power. There's a comparative aspect to this.
Explanatory power is easy when you have an omnipotent actor. Any and all things can be attributed to this actor. Now, predictive power becomes a lot harder. Basically, you can't predict anything reliably in such a case, and interestingly, intelligent design doesn't really make any predictions that have come true, and it doesn't even make many that haven't. It's basically dead in the water in terms of suggesting avenues for further research, and that's why scientific journals aren't getting floods of new cutting-edge experiments in intelligent design.
And so I would be happy to grant that Darwinism is a scientific theory. I just think that we've got a better one, and because it explains the key evidences more consistent in a way that's more consistent with our knowledge of cause and effect. So I tend not to want to say disqualify things with a definition. I want to show that our theory provides a better explanation in relation to the evidence. But there is this kind of weaseliness about neo-Darwinism. It's constantly reinventing itself to avoid, refutation. So yeah, thanks.
That's just a snarky way of saying the science of biology updates with new information. you know, kind of the whole point of science?
Hi, my question revolves around the concept of irreducible complexity. And I believe, if you can tell me if I'm explaining this correctly, there's a certain number of processes that need to be present in the cell for the cell to continue life. And if one of those processes is eliminated, if that number, I don't know if it's 130, 140, something, I believe. But if one of those processes is eliminated, that cell will die. It doesn't make a difference how many more exist. So, given that, how do secular biologists argue that all of these were present at one time and now we have life, rather than slowly accumulating all these processes at one time and still not being able to have life until you get to 140 or 150 or however many it take?
A few things. One, by any definition that is useful, irreducibly complex features can and do evolve. I've talked about it plenty of times before, but here's a link to Dr. Dan talking about an irreducibly complex structure that evolved in modern history, in HIV. Second, the fact that modern life is dependent on a certain number of such structures, such that any of them being missing is fatal, doesn't mean that the first life was so dependent. Right now, I require oxygen because while my cells can and do use anaerobic respiration, they can't do it enough or at a high enough rate to keep me alive without oxygen. This was not true of all my distant ancestors. And this might be overload, but here's him talking to Dr. Dan and failing utterly to defend his positions. And here also is a video in which I got to speak to Dr. Behe, and frankly, I wasn't impressed with his defense of his positions and hypothesis as something that could be reasonably called science.
Yeah, really, you did a nice job explaining this. Okay, the idea of irreducible complexity was first proposed by a biochemist named Michael Behe. I was with him last week in Pennsylvania, where he's from.
Here's a fun story. When Behe talked about this in court during the Dover trial to get Of Pandas and People, the creationist book we've already mentioned in this series earlier, kept in schools, Behe said that he hadn't found much research on the evolution of the flagellar motor. The cross-examining attorney then produced a printed stack of papers of that exact thing. I guess Behe didn't look very hard.
And Behe highlighted these little tiny miniature machines and circuits that are being discovered inside even the simplest cells. I wish I had the pictures. I shared some of this with the faculty this morning, but one of those little machines is called a bacterial flagellar motor. He made it very famous. It's literally a rotary engine.
That's why there was so much work going into researching it. Because it's cool.
It has a rotor, a stator, a U-joint, bushings, bearings, a drive shaft, and a little hook-like tail that functions like a propeller. It turns at 100,000 RPM. It's hardwired into a signal transduction circuit and can reverse directions on a quarter of a turn. It allows the bug to chase down the sugar it needs to eat. It's amazing, okay?
And amusingly, every single irreducibly complex structure Behe put in his book Darwin's Black Box is something that not only can evolve, but that sufficient research has been done that it can reasonably be said that it is known how they evolve. Like really, just do a search on Google Scholar. You'll get hundreds, if not thousands of hits on this.
High tech and low life. Behe argues that systems like this, there are many things that the mutation selection mechanism can explain, he said, but things like this it can't explain. Because the whole idea of mutation and selection is that natural selection preserves things that confer a functional advantage. But these machines that have all this one particular machine has about 30 protein parts. And if any one of those parts is missing, the machine doesn't work. And this is what you're alluding to. And this applies at higher levels as well. But when you break it down to these machines and circuits, it really becomes a very tractable engineering problem. And Behe shows that the 29, 28, 27, 26 part version of this motor simply has no function.
He alleges. He's wrong.
So the intermediate stages on the way from whatever simple thing it started with to the fully functional motor are simply non-viable, which means they won't be selected, which means that the evolutionary process will terminate in encountering those non-functional combinations of parts. So that means that you can't build the motor or these motors gradually in a step-by-step Darwinian fashion, but that's the mechanism that is allegedly gets rid of the need for the design hypothesis. That unguided, undirected mechanism of mutation and selection explains the appearance, but not the actuality of design, say the Darwinists. So Behe says, look, if there isn't a designer substitute mechanism that explains the appearance of design, and we have a striking appearance of design in these little nanomachines, maybe they really were designed.
There are basically two ways in which irreducibly complex systems tend to evolve. One is acceptation, in which a system that evolved for one purpose ends up being useful in another, and then refinements are made. This is the case with the bacterial flagellum, which evolved from some transmembrane transport proteins. The second is via a metaphorical scaffold. Think of a stone arch. Only with every stone in the arch in place will it stand. Remove just one and it'll collapse. So, how do you build something that can't stand without everything in place? Well, with a scaffold. Make a nice wooden scaffold that has the basic shape of the arch and brace the stones against it. After the final stone is in place, you can remove the scaffold. This is how things like the mammal blood clotting cascade can form. You have parallel and redundant ways of performing functions which are interrelated. Then if one of them ends up being able to stand on its own, the rest can end up mutating away with no significant harm or even with some benefit, such as energy saving. And you're left with the absurdly complex, and irreducibly so, mammal blood clotting cascade. Irreducible complexity simply isn't a problem for evolution, and this has been well known since Behe wrote his book in the first place. The only retreat irreducible complexity fans have is to simply say that such systems were never irreducibly complex in the first place, which just makes the whole thing unfalsifiable, and so, not part of science.
Hey, there's a concept. Yeah, so that's what, yeah, and what you asked how they explain this. What has been proposed is there are some intermediate structures that might show that the complexity is not irreducible.
Nope, it's still irreducible by Behe's definition. Sorry, but things that meet his definition can evolve.
And there is something that's been discovered called a little type 3 secretory system. It's a little syringe that has 10 parts, and it's actually in a fully built flagellum. It's on the inside, and then all the other parts get built around it. And in some bacteria, you find these little syringes operating in isolation. But what the people who want to invoke those as the intermediates on the way to the full system don't tell you is...
No one is hiding the ball in evolutionary biology papers. I'm not going to let Meyer just accuse his intellectual opponents of hiding things when this is the man who will tell an audience that mammals evolved in the Eocene, when in fact it was the Jurassic. He can clean out the plank in his own eye before he comes after the speck in the eye of professional scientists working and publishing in a field that he can't help but misrepresent. He doesn't get to finish after that on my channel. Sorry. And spoilers, he just lies about flagellar evolution. Or at least, if he's not lying, he's massively ill-informed.
My question is kind of a merging question of apologetics, methodology, and also this idea of presupposition.
Presuppositional apologetics is what you do when you don't think you have any reason for people to believe you beyond sophist word games.
As we're talking about this issue of irreducible complexity, it is very interesting because it comes down, my understanding, to an issue of presupposition. Because the evolutionary biologist is presupposing, like you said earlier, no deleterious mutations.
Excuse me, the f did you just say?
Nope. Deleterious mutations are well known and accounted for.
Only good mutations.
Nope, most mutations are neutral because they tend to occur in regions of the genome that are not sequence constrained, which means they can't really change anything. And even in the sequence constrained regions, they can switch between synonymous codons, meaning that there is in fact no change to the phenotype of the organism.
Resulting with enough time in some machine that you can build sequentially, which is really a presupposition that they presuppose that, first of all, it's not going to get destroyed along the way.
Nope, being destroyed along the way is part of natural selection and genetic drift. Again, that's part of evolutionary biology.
Second of all, there's enough time to do it. So my question then is, you think about presuppositions and the need for information, and you're looking for a better model that has information given, that is a designer. What about including in your apologetic, and maybe you do?
I like that Stephen Meyer is so obviously an apologist and not a scientist, that this guy just assumes he is one, despite Meyer's attempt to veil that fact behind the totally not religious Promise Guys Discovery Institute branding.
Other arguments of that nature of presupposition. The question of not only where do we get information from, what's a better explanation for information, but also what's a better explanation for certain laws of logic, certain laws of science. This is a transcendental argument that Bahnsen talks about in the presuppositional apologetics. So do you incorporate this argument for a need for a giver of moral law, a giver of logic, the very things that philosophy begs for, but then also, yeah, information that sort of relates to that too, isn't that?
Look, if you think that a god meets your philosophical requirements for how reality must be structured, then cool. It's not going to get you to Christianity, and attempts to do so always just come down to I'm right because I say so. Don't do presuppositional arguments. It's the least convincing form of apologetics.
I'm a big fan of both the moral argument and the epistemological argument for God's existence, the argument from epistemological necessity.
Cool, I don't care about this question. It's not scientific, which is okay, it's not meant to be. But this channel is primarily about science, and there's a reason I don't really address arguments for God that aren't based around scientific claims. We're skipping ahead.
I think it's interesting that the evolutionist, the atheistic evolutionist is doing that all the time because they're basically saying they're unwilling to allow for the possibility of a God. That's why they define it as naturalistic.
And there it is, my pet peeve. The Venn diagram of people who accept evolution and atheists is not a circle. There are non-atheists who accept evolution.
Well, there's a huge question about the reliability of human reasoning.
Hence science's dedication to testing and replicating results. The rest of this is Meyer's philosophizing. As I've said, I don't care about that, so I'm skipping it. And that's it. The rest of this is just Meyer making excuses for why there is essentially no acceptance of his ideas. It basically comes down to conspiracy theories and wishful thinking about evolution being a theory in crisis. So with that, we draw our discussion of Meyer to a close, at least for now. Thank you for sticking with me through this, and if you liked this video, don't forget to hit like and tell me what you liked or didn't like in the comments. And do remember to subscribe if you haven't, and turn on the notification bell so you're always notified when I post new content. I'm the Dapper Dinosaur. Thanks for watching, but before you go, I just want to say a special thank you to my channel members and my patrons, especially those pledging $20 or above. Work in Progress, Benthoven, Cynically Skeptic, Denny5252, Ian Chen, John Ackerman, Chris Love, Landon Noel, Yapetus, Mabbity Babbity, Sphincter of Doom, The Venerable Bede, and Patrick Dennis. As you probably know, YouTube is a very volatile platform, and from month to month my income on the channel can swing wildly. But the people you see on screen are directly supporting so that I don't have to worry too much about that, and the channel can keep going as it is, and perhaps even improving. If you'd like to join this team, there are links below to join the channel or in the description to join the Patreon. The Patreon starts as low as $1 a month, and the channel memberships start as low as $1.99 a month. On Patreon, you can even get a discount for pledging annually. If you do decide to pledge, you'll get access to an exclusive Discord server just for channel supporters, as well as early access to all of my pre-recorded videos, often up to 2 months in advance. Higher tiers will unlock even better perks. Now, if the annual or monthly pledge isn't right for you, but you still want to support the channel, there is a merch store down in the description, as well as an Amazon wishlist, just for me. And if financial support isn't something you can or want to do, then if you still want to help out the channel, please just like and share these videos and make sure you comment on them. It really helps the channel out. Thanks again for watching.